Good evening, everyone. Happy New Year. It's good to be back after a long break. I hope all of you all can hear me clearly. If you can quickly type in the chat window. If I'm audible, we can start in a couple of minutes. All my sessions is put in a playlist on the GMAT Club website. So for anyone, I would speak about, I would link some session, I would speak about something that I did in a previous session. Please go back, have a look at it. Right, this is a continuation of what we did with time and work. It's going to be a different, ball game with speed, distance, and time, but the crux deals with what we did in time and work as well. Great. All right, so let's start. If you've gone through the time and work video, there's going to be some tweaks that I make in the topic of speed, distance, and time. But more or less, I'm going to start from absolute scratch. I'm going to build on the topic. I'm going to put in some structures. I'm going to speak about particular concepts, and I'm just going to, put in everything that is required for you to go back and attempt different kinds of questions of different difficulty levels. Okay, I'm going to start with the foundations first. So people who already have those foundations in place, just bear with me. I need to cater to everyone during this session. All right. So let's start. Everything in this topic hinges on your understanding of the formula speed is equal to distance by time, right? Similar to the rate and work topic, rate is equal to work by time. I also explained something about the concept of proportions in the time and work session. I'm going to continue that here. Speed is always directly proportional to the distance provided the time is constant. And speed is always inversely proportional to the time provided the distance is constant. So for a fixed time, if you increase the speed, you're going to travel a longer distance. If you decrease the speed, you're going to travel a shorter distance. And for a fixed distance, if you increase the speed, the time would reduce. And if you decrease the speed, the time would increase. And because of this concept of proportions, we have the formula speed is equal to distance by time. Distance on the numerator, time on the denominator. Now, whenever we speak about speed, right, when we speak about speed, we also speak about speed in terms of average speed. Think about it from a logical standpoint, okay? I want all of you all to think about this from a very logical standpoint. Let me just go into this again. Okay, just a minute. I think I need the eraser and the pen. Yeah, that's here. Okay. When we speak about speed, right, we cannot travel at a constant speed in a real life scenario, right? The only time you can travel at a constant speed is if you travel in a straight line in vacuum, right? We never travel at a constant speed, right? We're always, if you think about it, you're traveling from home to your office. You're going to travel, at a particular speed for one part of your journey. You're going to stop at the signals. You're going to, reduce your speed when you make a turn. So we can never travel at a constant speed in a real life scenario. So what do we do at that point? Your speed is going to be different for different parts of your journey. So instead of breaking down the journey into multiple different parts and work with what the speed was for every different part, we speak about the concept of average speed, right? What is average speed? An average speed is a representation of a value of speed that describes my entire journey. Instead of worrying about each part, it gives me a value that describes the speed for the entire journey. And if I want to calculate the average speed, I cannot add the speeds of every part of my journey and divide by the number. Why? Because Average speed is weighted in nature. It depends upon distance and time. So if you're traveling for one part of your journey at 60 kilometers per hour, and then you're traveling for another part of your journey at 40 kilometers per hour, if I ask you what is the average speed of the entire journey, I can't do 60 plus 40 divided by 2. Why? Because your average speed depends upon the time that you take to travel at that particular speed, right? You could have traveled 60 kilometers per hour for only 1 kilometer, but you could have traveled 40 kilometers per hour for 99 kilometers. And you know that averages are always weighted in nature, right? So since you've traveled a longer distance, that means a longer time at 40 kilometers per hour, your average speed should be closer to 40 than to 60, way closer to 40. So remember, speeds are always weighted in nature. You can't add the speeds and divide by the number. So what do we do? If we need to find the average speed, since it's weighted in nature, we use something called the harmonic mean. If you don't know what the harmonic mean is, forget I said it. But we use something called the harmonic mean, not the arithmetic mean. So the average speed is defined, since it depends upon both distance and time, is defined as the total distance traveled divided by the total time taken. This is the universal formula of average speed, right? It's the total distance traveled divided by the total time taken. Now this formula can be actually tweaked. Let's say you're going on a round trip. A round trip is something where the distance is constant. Say you're traveling from A to B, and then you're traveling back from B to A along the same road. So when you travel along the same road, that is called a round trip. Distance will always be constant in a round trip. So in a round trip, you can actually tweak this formula of average speed. Let's take an example. Let's say that I travel from home to office at the speed of A miles per hour. Let's say I travel from home to office at the speed of A miles per hour. Let's say the distance from home to office is D miles. So if I have the speed, I have the distance, I can find out the time that I take from home to office. So time is distance by speed. So that would be D by A hours. Similarly, let's say the speed that I travel from office back home is B miles per hour. And let's say the distance from office to home, I travel along the same road. So it's going to be the same D miles. So the time that I take from office to home would be D by B hours. Now, if someone asks me to find out the average speed of the entire round trip, of the entire journey, obviously I would utilize the universal formula for it. So average speed is given to me as what? The total distance traveled. What is the total distance traveled? 2D. Divided by the total time taken. What is the total time taken? D by A plus D by B. Let me simplify this, right? Let me take the LCM on the denominator, 2D divided by, if I take the LCM would be AB. That would be DB plus DA. The AB goes on top. So the average speed would be 2D times AB divided by DB plus DA is on the denominator. I can take D common into B plus A. So you see what happens? The D cancels out to give me the average speed is 2AB by A plus B. So this is what you can tweak the average speed formula to. So the average speed of a round trip journey where the distance is constant is given by 2AB divided by A plus B. That's what we call the harmonic mean. I mean, if you don't know what the harmonic mean is, don't worry about it. You don't need to worry. It's not a part of the GMAT. The GMAT pertains itself to the arithmetic mean a lot, but it's 2AB divided by A plus B. So remember, whenever you have the distance to be constant and you want to make use of average speed, You can directly use 2ab by a plus b. Very useful, especially on data sufficiency questions as well. What is A and B? What are A and B here? A and B are the upward journey speeds and downward journey speeds, respectively. So, whenever I need to find the average speed of a round trip where distance is constant, I can directly go towards using 2ab by a plus b and set my question up. But if I don't have the distance to be constant, right, and the distance is different for different parts of my journey, I have to revert to the original universal formula: average speed is equal to total distance traveled divided by the total time taken. For example, if somebody tells me that I am traveling at, say, 40 kilometers per hour, and I travel a distance of 200 kilometers, and then I travel at a speed of, let's say, um, 60 kilometers per hour, and I travel the same distance of 200 kilometers. As soon as I see that my distances are the same, or they mention somewhere, you are traveling for X kilometers at 40 kilometers per hour, and you're traveling the same distance. They don't need to give you a value specifically. You're traveling the same distance at 60 kilometers per hour. As soon as I see that the distance is constant, if I need to find the average speed, I'll directly say it's going to be 2ab by a plus b. So average speed would be 2 times 40 times 60 divided by 40 plus 60, which would be 100. Right? So 6 4 is 24. 24 into 2 will give me 48 kilometers per hour. But if the same question was, you travel one part of your journey at 40 kilometers per hour, and you travel a distance of 200 kilometers, and then you travel a second part of your journey at 60 kilometers per hour, and the distance there is 500 kilometers. What is your overall average speed? Then I have to go with the baseline formula of total distance by total time. So what will be the time here? 200 divided by 40, that will be 5 hours. The time here will be 500 divided by 60, that will be 25 by 3 hours. And now I would say average speed is total distance divided by total time. That's 700 divided by 5 plus 25 by 3. Right? You can do the simplifications for it. So it will be 700 into 3 divided by 40. 15 plus 25 would give me 40. The 3 would go on top. And I would simplify to get to my answer. Right? So remember, what is average speed? Average speed represents the speed of the entire journey. Ideally, in a real life scenario, you're going to travel small distances at different speeds, right? What does average speed do for you? It gives you an overall value that represents a speed for the entire journey, right? So remember, keep this in mind. I'm going to write this down. Average speed describes the entire journey, not the individual moments within it. What do I mean by this? If I tell you that you're going to travel at an average speed, if I say that you travel at an average speed of 40 kilometers per hour, this is the speed for the entire journey. But if I ask you what should be your speed at half the journey, at the halfway point of your journey, I will not be able to say that the average speed at the halfway point of my journey is 40 kilometers per hour. Right? It can be greater than 40. At the halfway point, it can be less than 40. Remember, average speed always describes the average speed for the speed of the entire journey, not for moments within it. Right? For half the journey, I could have traveled at a really high speed for the first half and a really low speed of the second half. And my overall average for the entire journey will pan out to 40 kilometers per hour. Right? So this is very important for you to understand. Many test takers make a mistake here. They assume that if the average speed is 40 kilometers per hour at any distance, at you're traveling half the distance, quarter the distance, one third the distance, also you should travel at that same speed of 40 kilometers per hour. No. So remember, average speed describes always the entire journey, not the individual moments within that journey. And if you want to work with the average speed, universal formula is total distance by total time. And if you see that the distance is constant, you're going on to a round trip, then the average speed is defined as 2ab by a plus b, where a and b are the upward journey speeds and downward journey speeds respectively. Got this? Everybody, any doubts here? I'm building from the concepts, and then slowly we'll move into the different types of questions that you have. Any doubts? All right. Second, in this topic specifically, you're going to deal with a lot of unit conversions. In this topic and time and work, you're going to deal with unit conversions. The GMAT also, definitely would give you a question that deals with unit conversions on your test as well. When you're working with unit conversions, remember, simple rule of thumb, always maintain similar quantities along, or always maintain similar quantities across the same units. Okay, if you see that you have time, you have in minutes somewhere and in hours somewhere, either change the hours to minutes or the minutes to hours. Try to keep it across a common unit. Okay, and how do you make unit conversions here? You're expected to remember the conversions of distance. You're expected to remember the conversions of time. Okay, you're not expected to remember complex conversions like kilometers to miles, like feet to inches. They would give you the conversions at the end of the question in brackets. But when you see a unit conversion question, always remember the rule of thumb. Use your conversions, always convert quantities. Always learn to convert quantities via their units. Always remember, write down the number along with the units and then convert it based on what units they require. For example, if someone asks me to convert 36 kilometers per hour to meters per second, I will always convert it via the units. The units are more important for me. So 36 kilometers, I'll write this like this, divided by 1 hour. And I would write this further as 36 into 1 kilometer divided by 1 hour. And now I would make my conversions. I need to convert kilometers to meters, so that's 36 into 1000 meters. And I need to convert hours to seconds. That would be 60 minutes into 60 seconds. Now I would simplify. Right? So 6 6 are 36. That would give me 10 meters per second. So learn to do this, please, right? Always learn to convert quantities via their units. I see many people making mistakes for things like this. Say, you go to buy a piece of land and you bought like a 30-40 land, right? And 30-40 you say is like 1200 square feet, right? Say you bought a land of 1200 square feet. And I ask you to convert this into square inches. Okay, let's say you need to convert this into square inches. And I give you the conversion that 1 foot is 12 inches. Now, how would you make this conversion? I see many test takers make this mistake. They'll say 1200 square foot to square inches. So they'll say 1200 into 12. Right? Because 1 foot is 12 inches, and then they would write down the answer. Remember, understand the units well first. What does 1200 square foot mean? 1200 foot square. It's the length into the width. So basically, it's foot square. So use the units to convert. So 1200 into 1 foot into 1 foot. You see? Anytime I'm doing a conversion, I'm always doing it via the units. So 1200, 1 foot is 12 inches into 12 inches. Right? That would be 12, 12, 12, and 2 zeros. That would be my answer, square inches. So remember, this is something that you're going to find in this topic. Always try to maintain units, maintain quantities across the same unit. And second, convert quantities via the units. Write down the units for the conversion and do the conversions via the units. All right. That's the second. Now, third. Now we go into actual speed, distance, and time. All your speed, distance, time questions can be broadly classified into one of two types. A question where one body moves versus a question where two bodies move. They won't go beyond that. I think is that anything beyond three bodies, four bodies would be beyond the scope of the GMAT. But most of your questions can be bucketed into one of these two types, right? One body moves, two bodies move. What you need to do when you're working with a speed, distance, time question, you have to treat it like a word problem, right? So I always tell my test takers that when you work with a word problem, it's important when to read the question, process the information, and then jot down the information in a nice structured manner. Don't get into algebraical calculations from the beginning. So what do? The first thing you have to do when you work with a speed, distance, time based question, I'm going to write like a quick flow chart kind of thing. Read the question, read, process the information, visualize the question. This is the most important bit in this topic. Learn to visualize the question like a real life scenario and organize your information. That should be your goal when you read the question the first time. It shouldn't be towards creating equations and trying to solve from the outset. Once this is done, you're going to ask yourself, once you've read the question, you've processed it, you've visualized it, you've organized all the information that is given, you're going to ask yourself, is this question falling under a question where only one body moves? Or is it something where two bodies are moving with respect to each other? If you bifurcate the question like this, you can follow structures of what we can do with one body moves and follow certain structures of what we can do when two bodies move. Okay? So you're going to read, you're going to process, you're going to visualize. This is going to be the crux of everything that we're going to do today, right? The first thing we're going to do is we're going to read, process, visualize, and organize the information. We're going to ask whether it falls under a question where one body moves or two bodies move. I'm going to develop structures for what needs to be done when one body moves, what needs to be done when two bodies move. We'll work with one particular algebraic process of working, a very structured tabular format. And then we'll also explore other ways of working. What happens if you get too many variables in the question? What can you do with the concept of relative speed, right? I'm going to work the same questions, but with a different perspective. So people who are more visual in nature would prefer the relative speed process. People who are more algebraic in nature would prefer the algebraic structured process that I'm giving you. All right. Now, so I'm going to focus on one body moving first. We're going to build structures based on that. And then we are going to go with certain examples. So what do you do when you work with a question where one body moves? When you work with a question where one body moves, you are forced to go the route of setting things up using algebra. You can't do anything else. Using obviously the formula speed is equal to distance by time. So what do you do here? I'm going to write down the structures. You're going to read the question. You're going to process the information. You're going to visualize the question like a real life scenario. How do you visualize? I'm going to use this word a lot. How do you visualize? Put yourself in that scenario and ask yourself, right? If I was in this question and this was the information that was given to me, how would my mind process it? And organize the information in a nice distance, speed, and time table. Right? Many of you all would be doing it already. Many test takers already have that framework in place. I'm going to add certain things to that framework. Okay, I'm going to say how you can be more efficient putting your information well. Remember, it's a word problem at the end of the day. So if you don't focus on reading, processing, and visualizing, or just organizing the data is not going to hold you in good stead, because on harder levels of questions, how you read and process and visualize the information will take a lot more priority than putting the data in the form of a table. Okay. People ask me about the GMAT. I always tell them, right, the GMAT is predominantly a reading and processing question. There's a lot of reading involved, right? Active reading that you'll have to develop. So when you're working with word problems, learn to develop that process of reading and breaking down questions. So read, process, visualize, and organize the data in a nice distance, speed, and timetable. Whatever additional info they are giving you, which cannot be put inside the table, jot down the additional info on the side. They'll tell you that the total distance traveled is 12 kilometers, or they'll tell you one person traveled one person took half an hour more than the other person. So whatever additional information they're giving you, in addition to information about distance, speed, and time, jot it down at the side of the table. Third, and I would say this is the most important of the structures, always make a note of the constant. In a speed, distance, time question, whether one body moves or whether two bodies move, at any given particular point of time, there will always be one out of speed, distance, and time that will always be a constant. Make a note of that constant. The question may give it to you directly, the question may imply that. Make a note of the constant, write it down, box it up. Right? You may use it, you may not use it, utilize it, but trust me, the constant always helps at some point or the other. Then, once you create that table, finish the table, right? Create that table, define your variables for information that is not given to you, right? Finish the table. Right? Define variables for unknown pieces of information, but learn to limit the number of variables you choose. What do I mean by this? When you have relationships given, they tell you the distance is the same. I will not sit and write x and y as the distances and then write x is equal to y. Right? That would just be too tedious. If they're saying the distance are the same, I'll say let the distance be x. Right? If I'm going to define something to be, the speed, I call the speed as s. I call the distance as d. I'm not going to keep the time as t. Right? The time would be distance by speed, so t will be d by s. Learn to limit the number of variables. So when you have relationships given between quantities, you can always limit the number of variables that you bring in. And then finally, again, a very, very important guideline: set up the equations. Set up your equations either using the distance column or using time. Avoid creating equations with speed in a speed distance time question. Always try to set up your equations using distance and time. You can also make use of average speed wherever applicable. And where will it be applicable? When I have information given to me that I can make use of average speed. What is the information that I require for me to make use of average speed? I will need the total distance given to me and the total time given to me. In that case, I can make use of the average speed and work my way through. Or if they give me the distance is constant and they give me the upward and the downward journey speeds, I can make use of average speed. Again, the average speed process of working should only be used when you have these pieces of information available to you. Got it? So I've put in a structure here. I'm going to take a question. I'm going to use that question as a blueprint to show you what I mean by putting all of these points on the screen here. All right, so I'm going to shift to my PPT. And let's work with question 1. Remember what I said. It's very important for you to understand here that in the topic of time and work and in the topic of speed, distance, time, there's not too many concepts for you to worry about, right? But if you don't have concepts, what is going to be tested is how you structure your information, how you read and process information, how you visualize. And then finally, after you structure your information, how do you set up your equations efficiently? Somebody mentioned in the chat, it becomes too convoluted. The reason it becomes too convoluted is you make it too convoluted because you don't bring in the reading and visualization process. Understand this, your algebra always comes towards the end here. If you attack such a question from an algebraic standpoint first, you will always make it more complex than it actually is. But if you approach the question from reading, processing, visualizing first, organizing your information, what I call, right? I mean, during my tutoring sessions, I divide this into 2 parts. Whenever you work with the time and work question, it's like working a jigsaw puzzle. The first part, figure out the pieces of your puzzle. So when you're figuring out the pieces of your puzzle, you're not going to try to fit them together. You're going to put all the face down pieces face up. You're going to observe all the pieces available to you, and you're going to pick the right piece to start from, to build your entire question from. And then after you have that, you're going to try to put the pieces together in the second phase. So in the first phase of working with any time and work and speed distance time question, learn to figure out the pieces. So what is the first step? I said read, process, visualize, and organize in a DST table. So let's do that. Jane rode her bicycle to the repair shop and rode the bus home by the same route. So I'm going to pause there and I'm going to reflect on what I read. So I'm visualizing that I am Jane. I take my bicycle and I go to the repair shop, obviously give it for repairs there, and I take the bus home by the same route. What catches my eye is the same route. So immediately I'll make a note of that. Make a note of your constant, right? Box it up. Whether you use it or not doesn't matter. It will come in handy at some point. Now, read the next line. Excluding the time she spent at the shop, she spent a total of 1 hour traveling from her home to the shop and back again. So I'll write that down. That's additional information that is given to me. Total time is 1 hour. You see, I'm not worrying about putting equations at this phase. I'm worried about reading, processing, and organizing what I have. Figure out the pieces of your puzzle. If she rode her bicycle at an average speed of 5 miles per hour, here comes all the data. So I'm going to put in distance, speed, time. I'm going to organize the information in a nice table. She's riding the bicycle and then the bus. I'm going to call BI and BU. And they're telling me if she rode her bicycle at an average speed of 5 miles per hour and the bus traveled at an average speed of 20 miles per hour, then how many miles did she ride her bicycle? So I need to find out what is the distance that she's ridden her bicycle for. And I also know that the distance is constant, right? So let me say, let the distance be x here, x miles. Here also, let me keep it as x miles because it's constant. I can use the same variable. And you see, I'm defining my variable for the distance because it's a constant. I'm not going to keep another variable for time, right? What is time? Time is distance by speed. So that would be x by 5. That would be x by 20. This is what I have. And once I finish my table, like I said, right, always create your algebraic equations either via the distance or via the time. The extra information that the question provides will give you that clue. So what do you do here? I know the total time is 1 hour, so I can add the times. X by 5 plus x by 20 is equal to 1. I can take the LCM. That's 4x plus x is equal to 1. So 5x is equal to 20. X is equal to 4. And that's exactly what I want. That's what the question is asking me to solve for. B. So you see what I did, right? I did not dive in immediately, start creating equations out of it. I read the question. I processed the information. And how did I read it? I read it line by line, step by step. I read one line. I processed what it meant. I wrote down what I could. As soon as I saw data being given to me, I put it in the form of a table. I tried to fill the table first, figure out my pieces of the puzzle before I started putting everything together. I jotted down whatever they told me on the side. I put all the pieces together. So I'm putting an algebra process here. We will use throughout. I will not deviate from this process. Even the most toughest questions you'll have to bring in. But the tougher questions will also include a little bit of visualization. So we'll come to that when we have to, right? Also, what I could have done in this question, right? I told you, right, where I can make use of the concept of average speed if the question presents that opportunity for me. So here I do have the opportunity of making use of average speed. Why? Because I have the distance to be constant, and they have given me the upward journey speed and downward journey speed respectively. I have the distance to be constant, and I've given me the upward journey speed and the downward journey speed. So I can find out the average speed here, which will be 2ab divided by a plus b. This is an alternate approach to work. So that will be 2 into 5 into 20 divided by 25. So 5 5s are 5 4s are. That will give me the average speed for the entire journey. Remember, average speed is always for the entire journey. That means up by bicycle, down back by bus. So her average speed is 8 miles per hour. Now this is where if you're using average speed, you'll have to visualize and understand your data well, right? Where did the 4x come from? Okay, the 4x came from me taking the LCM, right? So x by 5 plus x by 20 is equal to 1. So you take the LCM of 5 and 20, which is 20. So 5 4s are 20, 4 into x is x, right? 4x. 20 ones are 20, that's x, right? So I'm just using normal addition of fractions. Guys, you need to be good, well versed with the fundamentals of algebra here. Like I said, there's not too many concepts. It depends entirely on how you read and process information, organize information, and how you break down your algebra. So you should be very, very good with manipulating algebraic equations. So coming back to what I was saying, The average speed here is 8 miles per hour. That's, remember, for the entire journey, up and down. And I know she's traveled a total time of 1 hour. So if my average speed for the entire journey is 8 miles per hour and she's traveled up and down for 1 hour, that means the distance that she's traveled in that 1 hour is 8 miles. So if she's traveled up from home to the repair shop and then repair shop back home along the same road, because the distance is constant, and the total distance is 8 miles, then obviously the distance that she travels by bicycle has to be half of that, which is 4 miles. That is also another way you can work with it. But remember, this question gave me the opportunity of exploring the average speed process of working. Why? Because I have the total distance and I had the total time and I could make use of it. Right? So wherever you're able to identify that the usage of average speed is possible, use it. If not, stick to this table format that I gave you. What is important for you to understand is read the question, process the information, don't get into creating equations from the first phase. Jot down the constant, write down the extra information on the side, fill up the table. Define your variables for unknown quantities in the table, limit your variables. And once you have the table and once you have all the information available to you, try to then piece them together based on what the question is asking you. Got it? And that's the format that I'm going to set here. And that is exactly what we're going to use going forward in all of the questions, even on data sufficiency. Got it? Any doubt here? Right? I gave you the alternative process as well. And how I worked with this question, right? I'm using this as a blueprint to tell you how you need to also practice in your practice phase. You see, I did not just work with it to get to an answer. I tried to explore what other possibilities are there. And it's only the reading process that will help you identify that you have the total distance and the total time for you to make use of the average speed concept. Can you go backwards and say time is 1 minus x and x? Absolutely, right? I told you, you can set up. So one more way of setting it up, if you want me to do it that way, guys. What is the point that I made? If you look at the guidelines that I gave you, right? I said set up your equations either using the distance or using the time. You want to set up with the time? Absolutely fine. It is not going to change too much. So let's see that. Right, so let me change things a little bit here. So what some people would also do is they would set things up via the time. I set it up via the distance here and I worked with it. You can also set it up via the time. So let's work with it. So let's say the total time you've taken is 1 hour. So let's say the time you've taken by bicycle is x. Since the total time is 1 hour, this would be 1 minus x, right? So I have the speed as 5 miles per hour. I have the time as x, 21 minus x. So the distance traveled will be 5x. And this is 20 into 1 minus x. And you know the distances are both equal. So you can say 5x is equal to 20 into 1 minus x, right? So 5 ones are 5 fours are. X is equal to 4 minus 4x. So you get 5x is equal to 4. So you'll get x is equal to 4/5 of an hour, right? Why I chose to go the distance route? Because the question asked me, okay, what was the distance? But you can absolutely do time. Now you've got x is equal to 4 by 5 hours. Don't stop there. Ideally, I would have given you 4 by 5 as one of the answer choices as well. So if you got 4 by 5 hours, remember that's the time. The question's asking you for the distance you travel by bicycle. I need 5x. So 5 into 4 by 5 would give me the answer to be 4 miles. So someone said that you can set it up with the time. Absolutely. The point I want to drill into your head is this. Make the table, fill the table. You have to learn to create your algebra either using the distance or using the time. What you choose to use will depend upon what kind of data is given and will depend upon what the question is asking you to solve. I prefer to use, solve for what the question is asking, but this is absolutely fine, right? So now you understand, right, why I've put those pointers in place. I've put in a structure in place. I want you to take that structure, right, and follow that structure as we move forward into other questions. And second, explore other opportunities as well. Can I use the average speed concept? Right? We'll also deal with something called relative speed when we go into two bodies moving. I'll explain that once we go into that point. Try to see if you can work with that as well. Any doubts here? Any doubts? Can we go into the second one? I'm going to, reinforce the process of working with the next two questions. So any doubts, please ask me at this stage itself. Okay. Here's question 2. I'm going to give all of you all a couple of minutes to work with. Remember what I said. Follow the approach. It's unlearning and relearning that you need to do. Read, process, visualize, organize first. Set up the table. Put in all the extra information on the side if there is. Figure out the pieces. Make a note of the constant. Then start putting the pieces together. Give it a shot. Please don't type in the answer in the chat window until I ask you to do so. Okay, you can start typing your answers in the chat window if you're done. What I want all of you all to focus on first is not to get into calculations, but first organize your information. Okay? Be a little careful in terms of units, but organize your information. Take stock of the information first. Then you'll be able to piece things together nicely. Work on the table. Don't try to work towards the question from the beginning. For those who've just joined in, guys, I've already put in a process, a structure in place, so you can just quickly, rewind the session to the place where I've put a structure of how to work with questions where one body moves. Take a screenshot, keep that on your screen, and attempt the questions. Right, like I said, there's not too many concepts for me to teach here, but it's about structures in how you break down information. Okay. So I see only a couple of people giving me an answer here. So for those who are not getting an answer, can you type in the chat window, what is the hard bit? Right? Where are you getting stuck? Right? So that is also absolutely fine. I'll cater to that. So are you getting stuck in too many calculations, like somebody said? Have you figured out what you need to do and how to you need to put the pieces together? So whatever you're stuck at, right? Type in the chat window and I'll try to cater to that. Nobody? Could not set up the structure, processing the info, and what all variables to use. Like I said, right, guys, what is important in this topic is how you set things up. Okay. So if you don't read, you don't piece the information together, you'll normally struggle with this. But if you get the process of reading in place, right, and this is ideally something you should do when you start with your word problem preparation, right? Many test takers just solve word problems just by randomly picking variables and working, rather than focusing on trying to read and visualize and engage with the question and pick variables smartly. You normally would pick variables for whatever quantities are present in the question. So this is exactly what I'm going to do here, is exactly what you need to do on word problems as well. I'm going to read, process the information first. I'm not going to do any calculations from the outset. A car traveling at a certain constant speed takes 2 seconds longer to travel 1 kilometer than it would take to travel 1 kilometer at 75 kilometers per hour. So, what are they telling me? I have a car. That car will take 2 seconds longer to travel 1 kilometer if it's traveling at some constant speed than it would take to travel 1 kilometer at 75 kilometers per hour. So if it's traveling at 1 kilometer at 75 kilometers per hour, whatever time you get there, it's going to take 2 seconds longer than that. Right? So immediately I would say, okay, what does this mean? Let me put the information into that table. What is the first scenario that I have? A car traveling at a certain constant speed takes 2 seconds longer to travel 1 kilometer. So my distance is 1 kilometer. It takes 2 seconds longer than what? Than it would take to travel 1 kilometer at 75 kilometers per hour. Now I know if it takes one, if it travels at 75 kilometers per hour and travels 1 kilometer, I can immediately find out the time. That will be 1 by 75 hours. And I know the time here should be what? 1 by 75 hours plus 2 seconds. Because you're telling me, right? The time is 2 seconds longer in the first scenario. So since I have everything in terms of hours and seconds, right, I want to keep that across a common unit. I'll change everything to seconds. So I'll write 1 by 75 hours as 1 by 75 into 3,600 seconds, right? 1 hour is 3,600 seconds. So 1 by 75 hours is 1 by 75 into 3,600. I'll simplify that. 25 threes are 25 ones are 25, 25 fours are 100, again 125 fours are 100, 3 fours are 12, 3 eights are 24. So that's 48 seconds, right? So this boils down to 48 seconds once I make the conversions. And they are telling me that the first scenario takes 2 seconds longer. So if it's taking 2 seconds longer, then this should be 50 seconds. And they're asking me to find out at what speed in kilometers per hour is the car traveling. So they need me to find out this s kilometers per hour, right? I need this. Simple. So what have I done? I first focus on setting up my data. It's a very easy question. It's not a difficult one. I focused on reading, visualizing, setting up, and understanding the information first. I tried to keep everything across a single unit, and now I'm trying to piece things together. So I need the speed. Speed is equal to distance divided by time. So speed will be 1 by 50 kilometers per second. But remember, I want it in kilometers per hour. So 1 by 50 into, again, 3,600, right? So if it goes, 5 sevens are 35, 5 twos are 10. So the speed is 72 kilometers per hour. Got it? For you to understand how I got the 3,600, break it down into parts. 1 by 5 kilometer, 1 by 50 kilometers, right, per second. That means you're dividing it by 1 second. So 1 by 50 kilometers into 1 by 1 second, right, into how many hours divided by 1 second is 1 divided by 3,600 hours, right? So 1 by 50 into, you take the reciprocal, 3,600. That would be kilometers per hour. That gives me 72 PE. There's no other alternative on these kinds of questions, right? I told you what this topic tests you, and why test takers don't like this topic as well is because it boils down to how you process information, how you organize information, how you're well versed with the mathematical data that you have. And then after that, you need to piece things together step by step by step. Got it? So what did I do first? I focused on forming my table here with data. I did not worry about calculations at the first stage. I put in the information, right? I got one equation with two unknowns. Which variables to select? I'm struggling with the final answer. I'm getting a different number, for sure doing something wrong. Till here, I got right, but while finding speed, I went wrong. I didn't convert it back to hours. Yes. So that's where reading becomes a very important skill set, right? I told you, be aware of the units that you're dealing with. It's asking you kilometers per hour. Understand that you're working with seconds here. So I need to convert it back, right? You see, I did not go into converting 75 kilometers per hour to kilometers per second, right? That would have been two ugly calculations. Instead, when I got 1 by 75, 1 by 75 hours, I know that 1 by 75, again, I don't want a fraction. It would be better for me to change that to seconds. So that was decision making that I ended up doing, right? So I converted the time to seconds, and it was 2 seconds more, right? So I added 2 and I put 50, and then I converted it back when I had to convert it from kilometers per second to kilometers per hour. And you see how I did the conversions. For people who did not understand how I got the 3,600 directly, this is the process. 1 by 50 kilometers divided by 1 second, right? So if 1 hour is 3,600 seconds, then 1 second is how many hours? 1 into 1 divided by 3,600. So 1 by 3,600 hours. It's like what we discussed in the last topic of rate, time, and work, the concept of proportions, right? You cross multiply here. So I change that to hours by dividing by 1 by 3,600. To change the division to multiplication, you flip it around and then you do the calculations, right? So you see what I did, right? Again, my focus is all on reading, processing, putting in the information right, and then taking a good call on what to do and what to convert. Got it? All right. Okay with this? All of you all? Again, it's an official question, not a difficult one, but Test takers tend to make this topic a lot more difficult than it is. Why? Because they don't focus on the requirements. Again, what I want you all to do in the next question, focus on reading, processing the information, putting the information nicely, organizing it in the table, writing down whatever extra information you have at the side, and then try to put the pieces together based on the question. Okay, you have to make that effort and make that and do that unlearning and relearning for you to get better at this topic. Okay, all right, let's go to the next question. 3, another official one. Again, I'll give you all 2 minutes. Time starts now. Guys, follow the structure. Don't get into calculations. Read, process, visualize, organize your information in the table, set everything up, write down the extra information on the side, then take stock of the information, and then see how you can piece things together. All your algebraical working will all boil down to either working with the distance column or the time column. Okay. Okay, you can start putting your answers in the chat window. Again, if you're not getting it, mention in the chat window where are you stuck, right? So that in my explanation I can cater to that as well. You need to be efficient with the algebra, guys. Okay, you need to know how to break things down. I'm not picking questions that are, you know, completely difficult, right? These are official questions. The first three, all the first three questions that I picked are official ones. If you're wondering how to get a root of a number and it's a slightly bigger number, think about your number properties concepts, right? If you're not able to look at it and figure things out, I got one equation with two unknowns. If you've got one equation with two unknowns, you've not organized the table well and you've not taken stock of the information well. That is that is priority number one, Novasek. Okay, that is priority number one. You need to focus first on understanding the data and organizing your information, not get into working with equations. Okay, when I say understanding your data, put in whatever data you can in the table, and if required, you want to introduce variables for any unknowns you introduce, but you always try to limit the variables. You try to see if you can make do with whatever variables you have in the first place before you start introducing new ones. Got it? All right. A boat traveled upstream 90 miles at an average speed of v minus 3 miles per hour, and then traveled the same distance downstream at an average speed of v plus 3 miles per hour. So immediately I'll write down that the distance is constant. You see, I'm reading and I'm engaging with the data. They're giving me data, nice data for me to put in the form of a table. Distance, speed, time. This is where most of y'all are faltering, and this is why this topic is difficult, because y'all don't focus on the reading and processing of the information. I'm asking you to spend time on doing that. So a boat traveled upstream 90 miles at an average speed of v minus 3 miles per hour. So immediately what can I do? I can say that time is 90, time is distance by speed. So 90 divided by v minus 3. Try to use the information to your advantage, right? Everything boils down to the fundamental usage of speed is equal to distance by time. If they've given you the distance is 90 and the speed is v minus 3, why would I introduce another variable for the time? Now read the next bit. And then travel the same distance downstream at an average speed of v plus 3 miles per hour. So 90 miles again, v plus 3 miles per hour. So immediately I can get the time, 90 divided by v plus 3 hours. Hours. If the trip upstream took half an hour longer than the trip downstream, it's obvious, right? You're going upstream means you're going against the flow of current. You're going downstream, you're with the flow of current, so you'll take longer upstream. So I'll write down that extra information on the side. The trip upstream took half an hour longer than the trip downstream. So it's the trip downstream plus half. This is the information, extra information given to me. Then how many hours did it take the boat to travel downstream? So I need to solve for 90 divided by v plus 3. You see what I'm doing? I'm first trying to understand the question and put in as much information, organized information that I can. Fill up the table fully, see what extra information is given to me, and then try to break things down. So for people struggling with this first bit, you would have struggled with the entire question, because it's important that you read the question like how I did. I read it in parts. I didn't read the entire question. I read the first line, reflected, jotted down. Second, reflected, jotted down. And I tried to fill up as many blocks in my table as possible. Extra information, I wrote it at the side. Now, like I said, use either the distance column or the time column to set up your algebraic equations. So I know the distance upstream is half r longer than the distance than the time downstream. So I know 90 divided by v minus 3 should be equal to 90 divided by v plus 3 plus half. So 90 by v minus 3 minus 90 divided by v plus 3 is equal to half. I will take the 90 common. 1 by v minus 3 minus 1 by v plus 3 is equal to half. I'll simplify. I'll go on top here. So 90, taking the LCM. The LCM is v minus 3 into v plus 3. That's v square minus 9. And that will be, I'll just write it as v minus 3 and v plus 3 for not confusing some of y'all. So v minus 3, v plus 3. So this will be v plus 3 minus v plus 3, right? Is equal to half. So many of you would have made a mistake at this point. If you've made a mistake, right, you'll make a mistake with the negative sign here between the two terms. When you take the LCM, it's going to be v plus 3 minus of v minus 3, right? So many people have only put the negative on the v and forget the negative on the minus 3 as well, right? And then make a big blunder and then work with things. So be a little careful with how you work with the algebra. So this goes, so 90 into 6 divided by v square minus 9 is equal to 1 by 2. So 96 is 540. 540 into 2 is 1080 is equal to v square minus 9. So v square is equal to 1089. So v will be the square root of 1089. It should be plus or minus, but I'm not going to consider negative because v has to be a positive quantity. Now, for those who got to this point and then got stuck, what should I do with the root of 1089? You don't have a calculator facility on the quant section. You do have it on the DI section. So what do I do here? See, one thing that I would always suggest, right, when you have ugly calculations with numbers like this, the units digit will always give you the biggest clue on what you need to do, right? And if you know fundamental squares of numbers, it will help. I know it's going to end with a 9, right? So think about the squares. So if it's going to end with a 9, I should have my number either ending with a 3 or a 7, because a 3 square will give me a 9 or a 7 square would give me a 9. It's not a quadratic, right? I mean, v square is 1089. It's a quadratic, but I don't need to use any quadratic form to solve here, correct? So just 1089. All you can do, v square minus 1089 is 0 and then work, right? It's just the root of 1089. And I know that 3 square is 9, right? 30 square. 30 square is 900. That everybody can figure out. And 1089 is pretty close to 900, right? So I would go and attempt 33 square, right? 33 square is 33 times 33. 33 into 3 is 99. 33 into 3 is 99 plus 9 is 108. That would give me the answer. So we should be 33. Ideally, this would be the best way to work. If not, go ahead and break it down, right? Factorize it and work with it, right? So 3 3s are 9, 3 6 are 18, 3 3s are 9. 3 can go again, 121, and then you'll get 11. 11. So 3 square into 11 square. So you're doing root of 3 square into 11 square, which will be 3 times 11, which is 33. That's another mathematical process of working. So you've got v is equal to 33. Don't pick that. I mean, there's no answer anyway, but don't stop there, right? What is the question asking me? See, I put the circle and put a question mark around what the question is asking me. Why? Because there's multiple pieces of information in such questions. So be aware of what you need to solve for. So 90 divided by v plus 3 is what I need. So 90 divided by 36. 6 6 are, 6 1s are 6, 6 5s are 30. 3 2s are 6, 3 5s are 15. That's 5 by 2. That will give me 2.5. That's my answer. Again, what happened in the end was obviously it turned into a complete algebraic format of working. I have to work with algebra. But what you have to understand is, first, you have to organize this information this way before you can use the algebra, before you connect the dots. Right? That's why I said focus first on figuring out the pieces well. Then you'll be able to fit the pieces together. Right? So why test takers struggle on this topic is because they focus only on the algebra. They don't focus on the organization of the information, visualization of the question, the reading of the question. Right? And what happens when you have too many variables set up, your algebra also doesn't become very efficient to work. Make sense? Any doubts? Again, you see a pattern that's forming here, right? How important it is for you to read and organize the information. And then also how efficient you are with the algebra towards the end. Got it? Any doubts on this? Slowly, I'm going to increase the difficulty levels as well, right? And you'll see the format is still going to remain the same. Organization first, visualization first, then putting the pieces together using the math. Any doubts, guys? Since the question spoke about upstream and downstream, right? I'm just going to add a couple of things here. I would want to, do that. I'll do that in the. See, whenever you get a question that deals with upstream and downstream, in this question you didn't need to utilize it too much. It's just about organizing the information that you had. But when you have a question that deals with upstream and downstream, you have to understand that if you're traveling in a boat, right, and you're going upstream, there are two speeds that you'll have to take into consideration, right? The first is the speed of the boat, and the second is the speed of the current or the speed of the stream, right? Because that's something I just cannot overlook, right? Water will keep moving at some pace. So when you're going upstream, visualize it. It's similar to you climbing up the stairs. You find it harder climbing up the stairs. Why? Because when you're climbing up the stairs, you're going against gravity. Gravity is what's pulling you down, correct? It's going against against the direction of motion that you are going, right? You're going to go up and gravity is pulling you down. So obviously you'll find it harder to climb up the stairs. Similarly, if you're trying to go upstream, upstream means you're going against the flow of the current. So obviously you're going to find it harder because the speed of the current is going to impede your progress. So when you go upstream, your overall speed, let me write it as the speed upstream. Your overall speed will obviously be the speed of the boat minus the speed of the current, right? You'll have to subtract that. Why? Because it creates a retardation. But if you're going downstream, it's like you going down the stairs, right? You find it very easy to go down the stairs. Why? Because you're going with the flow of the current. You're going with the flow of gravity, right? So same way, if you're going downstream, you're going with the flow of the current. So if you're going with the flow of the current, the speed of the current will aid your movement. So the speed downstream should always be the speed of the boat plus the speed of the current. I want you to keep this in mind, right? It may come in handy when you work with upstream and downstream. When you work with a question where you're going upstream and downstream, remember two speeds have to be considered: the speed of the boat as well as the speed of the current. All right. Okay. Let's look at question 4. This is going to be the theme, okay, of all our discussions today. It's about reinforcing that structure, organization, reading, processing, taking stock of the information, and then piecing it together in terms of efficient algebra. All right. The more questions become harder, the more the visualization bit comes into play, and you'll see that as we go further, right? So here's question 4, another official one. Give it a shot. The reason, Sri Harsha, why we set up things in terms of distance and time is because I can add distances, I can add times, I can't add speeds up, right? Because speeds are not, speeds are always weighted in nature. Speeds depend upon the distance and the time. correct? If you're traveling at 40 for one part of the journey and 60 on the other, I can't say your overall is 100. No, I can't add speeds, I can't subtract speeds. So since I cannot do that here, I don't want to utilize that quantity to set up my equations because I can't algebraically manipulate data with speed. Understood? It's similar with what you do on time and work. When you work with time and work, right? When we form the table, the RTW table, you always try to use the rate and the work, right? And you create your algebraic equations around it. You don't work with the time there because think about it, right? If you're taking 1 hour to do a piece of job, a piece of work, and somebody else is taking 2 hours, together you will not take 3 hours, correct? So you can't add time, subtract time, manipulate time algebraically in the rate, time, and work format. So we form the equations with rate and work. In the speed, distance, time format, I can't add speeds or subtract speeds because they are harmonic in nature. They are dependent on the times. So we always utilize our equations based on the distance and the time done. Okay. Good question, by the way. Guys, organize your information first. Okay. Don't get into solving. Simple advice to all of you all: slow down in the beginning. If you slow down in the beginning, you will get faster towards the end. Okay, that's the biggest takeaway you can have when preparing for the GMAT. Slowing down is the best way to scoring well. Give all of you a couple of more minutes. Ahmed, no, that's not the right answer. Focus first on organizing the information, Ahmed. Then, once you have that information in place, you found what is required, then visualize the question, draw it out, draw out the scenario to understand it. You'll understand it a lot better. Okay. Many test takers don't do that. They don't work with a pen and paper when it comes to visualization. But if you draw it out, no, you'll understand it a lot better. Guys, remember what I said? When you're traveling upstream and downstream, right, you have to factor in that there are two speeds that are at play here, right? The speed of the boat and the speed of the stream. So imagine that you are the man, right? So when I say visualize the question, put yourself in the scenario. Put yourself in that boat and you're going downstream, then you're going upstream. Set up the data like that. Read the question like that, okay? With an attention to detail. Good. I see people are giving me answers. Ahmed has changed 3 answers so far. Guys, remember it's not about getting it right or wrong, right? It's about ensuring that you're learning the process of working here, right? And I want you to make these changes. Trust me, right? I mean, even in personal tutoring, many test takers find it hard to get rid of the older habits, right? So the only way you can do that is to slow down, follow the structures that I've put in, learn to engage with the question a lot more. Okay, you'll realize that will also be a key skill set that you'll require on the DI section. Most test takers, again, don't like the DI section because they don't develop those skill sets that are required for the DI section. This is one: reading and processing information efficiently. Okay. All right, so let's work with it. I want you to see how I organize information, and I'm going to solve it, and I'm going to set things up exactly like how I would have done in test A. Okay. Again, I'm going to read and visualize the question first. A man rows for 3 hours downstream and then for 3 hours upstream. Now I'm going to pause there. Okay, he's rowing equal amount of time downstream and upstream, but in my mind, I know that if he's traveling 3 hours downstream, he's traveling with the flow of the current. So in that 3 hours, he's definitely traveling at a faster pace. So he will travel more distance downstream and lesser distance upstream in that same time of 3 hours. That's what I'm visualizing in my mind. You see, I'm not getting into looking at only the words of the question in terms of numbers. I'm engaging with the question. I'm creating mental pictures in my mind on what I'm reading. In this whole process, he covers a distance of 12 kilometers. So whatever distance I go downstream and I go upstream, that total distance is 12. The biggest mistake test takers will make is they'll take it as 6 and 6. For those who did that, you didn't engage with the meaning of the question. You didn't visualize it like a real life scenario. If I'm going downstream, I should travel more distance than I travel upstream. So that 12 is not split into two equal halves. If the speed of the stream is 1 kilometer per hour, they've given you that. For how much more time will you have to row upstream to reach the starting point? So if I visualize it, I'm going 3 hours downstream. So I've traveled a larger distance, a longer distance downstream, and then 3 hours upstream. So I've traveled some distance back. But since upstream I'm traveling at a slightly lesser speed, I wouldn't go back to my starting point, right? So they're asking me how much more time should I take to reach the starting point. So see what I'm doing? I'm trying to understand my question first, visualize it like a real life scenario. Now I would put in my data, right? I have D, S, T. A man rows for 3 hours downstream, so I'll put down. That's given to me as 3 hours. And 3 hours upstream, 3 hours. In this whole process, he covers a distance of 12 kilometers. So I'll say the distance downstream plus the distance upstream is 12 kilometers. I'll make a note of that data at the side of my table. If the speed of the stream is 1 kilometer per hour, that's another extra piece of data given to me. How much more time? So I know if the speed of the stream is given to me, they've not given me the speed of the boat. So I have to define my variable based on that. So let me keep the speed of the boat as x kilometers per hour. So if I keep the speed of the boat as x, then downstream, I'm going to travel x plus 1, the speed of the boat plus the speed of the stream. And upstream, I'm going to travel x minus 1, the speed of the boat minus the speed of the stream. Now I've defined my variable for the speed. I've got my speed. I've got my time. I'm not going to put another variable for distance, right? And make it more convoluted. I know distance is speed into time. So 3 times x plus 1 is my distance. 3 times x minus 1 is the distance. Now I'm going to piece the information together. I know they've given me this extra information that the total distance downstream plus the total distance upstream should be 12 kilometers. What can I do? I can use distance, the distance column, to set up my equations. 3 into x plus 1 plus 3 into x minus 1 is equal to 12. I can knock off the 3's, that's 4. So that's 2x minus 1 and plus 1 cancels to give me 4. So x would be 2. So x is 2 kilometers per hour. So I've got the speed of the boat. I've calculated the speed of the boat. Now, what is the question asking me? For how much more time will he have to row upstream to reach the starting point? So let's visualize his journey. He started at this point, say that point, and he's traveled 3 hours downstream. So if he's traveled 3 hours downstream, I know the speed downstream is going to be 3 kilometers per hour. So the distance he's traveled is 9 kilometers downstream. He's traveled 9 kilometers downstream. Right? And then he's traveled 3 hours upstream. So 3 hours upstream, that means he's traveled at 2 kilometers per hour. And he's traveled for 3 hours, right? So that's 2. Sorry, this is 1 kilometer per hour. That's 2 minus 1. And he's traveled for 3 hours. So he would have traveled 3 kilometers upstream. So from here, he travels 3 kilometers upstream. Now this is where he is at. He's not reached the starting point again. What does the question ask me? For how much more time will he have to row upstream to reach the starting point? So I need to find the time. So if I need the time, I need the distance that he has to travel upstream, and I need the speed that he has to travel upstream. What is the distance that he has to travel upstream? 6 kilometers. Right? Time is distance by speed. And what is the speed he's going to travel upstream? The speed is going to be 1 kilometer per hour. So the time he would take would be 6 hours. That is my answer. That's one way to work. This is one way to work. I'm sticking to the process. See, in all the questions that I picked, all official questions, I'm focusing on how to organize the information on the table, and I've worked. I have not deviated from that process at all. Got it? We'll look at another process as well, right? But did all of you all get this? Did you all understand this? For people who didn't get it, look at what I've done on the screen, compare it with what you've done, and learn from where you got stuck. If you got stuck at a particular point, ask yourself, what should I have done better to organize my information? Is it because of the reading? Is it because I got caught up in too many pieces of information, introduced too many variables? Try to figure out the mistake and try to streamline your working to what I'm suggesting here. Got it? Any doubts in this process? See, as the questions become more and more tougher, the visualization bit is going to come into play. You'll have to learn to visualize the entire movement. Okay. And if you go into two bodies moving again, visualization is going to play a very, very important role. Okay with this? Okay with this format, this process of working? Any doubts here? No? Okay. How many of y'all in this, there are 32 people here. How many of y'all, when y'all read the question, identify that you could make use of average speed here? Because I had the total distance traveled and I also had the total time taken for that entire 12 kilometers. How many of y'all identified that I could have made use of average speed? Doesn't matter if you did it, executed it, but did you identify that I could have used average speed because I had the data for the total distance, that's 12 kilometers, and the total time, that was 6 hours? If you identified that, then a lot of calculation could have been bypassed. I had the total distance. Let me use the table itself. Okay, I removed it. I had the total distance as 12 kilometers, right? So immediately when I saw that the total distance is 12 kilometers. I know the total time to travel that distance is 6 hours. Immediately, I could find the average speed. The average speed here would be 2 kilometers per hour. Remember, that average speed is the speed of the entire journey. Now, since I've got the average speed, that's 2 kilometers per hour, that would actually be the speed of the boat, right, for the entire journey. So now I know the speed of the stream is 1 kilometer per hour. So I could write the speed upstream would be 3 kilometers per hour. The speed downstream would be 1 kilometer per hour. And now I could visualize it. I'm going 3 hours downstream. So if I'm going, sorry, this is the reverse. Upstream would be 1 and downstream would be 3. So I'm traveling downstream 3 kilometers per hour for 3 hours. So I've traveled 9 kilometers. And then upstream at 1 kilometer per hour. So 1 kilometer for 3 hours upstream would be 3 kilometers. I still have a deficit of 6 kilometers to travel. And I'm going to travel that 6 kilometers at the speed upstream, which is 1 kilometers per hour. So I would take a total time of 6 hours to work. That's my answer. Again, right? See, it's what's important in this topic is how you make sense of the information that is given to you. How you make decisions, understand the information really, really well. So whenever you have the option, right, of having the total speed and the total time, or you have the distance is constant and you have the upward journey and downward journey speeds, average speed becomes a process that is open to you to usage. But if not, if you're not able to identify it as well, no problem. You can stick to the process that we work with. That process will work for every question. I told you, even on data sufficiency, we are not going to deviate from the process of working. Correct? All right. Any doubts here, guys? Do you understand the point I'm trying to make here? Right? The point I'm trying to make, is this topic is not a test of your mathematical skill sets, right? It does test you on algebra later, but it's a test of how you read and organize information. As long as you start understanding that and work towards that, you start getting much better at this topic, and that will carry forward on harder topics like probability as well, where visualization comes into play, right? Other topics like time and work, other topics like data insights based questions where you'll have to read and process information. So either organize your information well, take stock of the information work, or try to make sense of the data and try to find out if you can use average speed and work with it. I don't need you to identify average speed. As long as you're able to set up the table and organize the information efficiently and piece things together, you're good to go on this topic. All right. Okay. So before we go forward, we've taken a good set of examples, right? We've taken a good set of examples for where one body moves, right? Let's take examples now for two bodies moving. Okay. Similar structures, just a couple of add-ons here, right? With two bodies moving, your focus has to be on trying to graphically represent the entire question. Okay. Meenakshi, you said something that you didn't understand. You didn't understand the previous question? Okay. All right. Let's continue then with two bodies moving. There is a certain tweak you'll have to make here. It's pretty much the same process that we've used so far, but the visual aspect comes into play in addition to structuring your data. Your focus on a question where two bodies move is to try to visualize the question. And like I said, when two bodies move, finding what is constant is really important. And same logic applies. Try to create your equations via the distance, via the time. So, what would I do in a question where two bodies move? First, I would always graphically represent the question. So, how I'm going to tackle this part of the discussion, guys, is we will stick to the process that we've got so far. We've used the algebra process. We will stick to that process and see what tweaks we have to make to the algebra process to solve even questions where two bodies move. I will solve one of the questions where two bodies move using the algebra process. And then I will go into an explanation of how we can use something called relative speed and cut down a lot of algebra, but bring in a lot more visualization. And we'll work the question using a relative speed process as well. And then we'll set up certain guidelines on where you can use the relative speed, how much to use the relative speed. And that's the alternate that you have. Okay, so I'm going to first stick to the algebra process, add the tweak that is required for two bodies move, and then look at the relative speed bit of working. So first, the algebra process, learn to graphically represent the question. What do I mean by this? Visualize the movement in your head. Set up the graph such that set up the graph to represent points from which the two bodies move simultaneously with respect to each other. Don't randomly draw it out, right? Try to set it up in such a way where, at some given point of time, the two bodies are moving simultaneously. Second, if the question deals with a point at which they meet, right, mark a logical meeting point in your graph. Right? That's the first thing I would do. I have to attack these questions from a visual aspect first. Right? And then I'm going to follow the same structures of what we did in a one body moving question. I would read, I would process, I would visualize, and organize in a DST table. And third, I would definitely make a note of the constant. And finally, I would put all the pieces together and create equations using either the distance or the time. Okay. Let's take an example, like how we did in the one body moving. Let's take an example and let's work with it. Okay. Let's try question 6. We'll do question 5, as we go forward as well. I want to use question 6 as a blueprint to work with things first. Two trains started simultaneously from opposite ends of a 100-mile route and traveled towards each other on parallel tracks. Okay. So I'm going to draw it out. You see what I'm doing? I'm first trying to visually, graphically represent my question. Two trains travel simultaneously from opposite ends. Simultaneously means from opposite. I know I have to draw two tracks. I'm just putting one track, right, to make it simpler. So they are traveling simultaneously. So I'm putting the arrows towards each other, to represent the direction. on parallel tracks of a 100-mile route, taking stock of the information, graphically representing it. Train X, traveling at a constant rate, completed the 100-mile trip in 5 hours. Immediately I'll stop. Okay, they're giving me X has completed the 100-mile trip in 5 hours. Immediately I can find out using this information. I can find out the speed of X. Right? I have the distance, I have the time. So 100 by 5, which is 20 miles per hour. I'm going to write that down. Train Y, traveling at a constant rate, completed the 100-mile trip in 3 hours. So I can find out the speed of Y as well. That will be 100 divided by 3. I'll leave it as it is. I'm not going to use decimals in my calculations. That's something I want you to notice as well. 100 by, sorry, let me do it again. So this is X, that's 20 miles per hour. That is 100 miles. And that's Y. They're moving towards each other simultaneously. And that is 100 by 3 miles per hour. Like I said, I'm going to put in the information that I have. I'm also going to mark a logical meeting point, right? Now, clearly X is traveling slower than Y. And they both are moving simultaneously. So this is the visual bit you need to bring in. X is traveling slower than Y. And both are traveling simultaneously. They're moving simultaneously at the same time towards each other. So where do you think would they meet? Would they meet closer to X or closer to Y? It's obvious they would meet closer to X, right? Because Y is traveling faster than X. So I'm going to put a logical meeting point here. I'm going to call that O. Immediately, when I read the question, how many miles had X traveled when it met train Y? They're asking me to find the distance that X travels. And I know that it has to be lesser than half, right? Because halfway means they're traveling at the same speeds. I know Y is traveling faster. So it's obviously going to be closer to X. So I know I can eliminate C, D, and E as my answer choices, right? I can eliminate C, D, and E, right? And I'm left with two possibilities. That's one way of looking at things. That's one way of being aware of the information that you've been given. But let's work with it, okay? So I've drawn it out. Now I'm going to integrate my table as well. You see, I'm focusing first on the visual aspect. I'm not worried about solving. So now, X, Y. The speed of X is 20 miles per hour. The speed of Y is 100 by 3 miles per hour. Right? Now I told you I can either make my equations via the distance or via the time. Now, since I know they are traveling towards each other and they're traveling simultaneously traveling simultaneously means they're traveling at the same time. The time that X would travel to reach O would be exactly the same as the time that Y would take to reach O. So I know the time here is constant. So I can call the time as T in both cases. I can find the distance, that will be 20T, and this would be 100T by 3. And I know the two distances, this distance that traveled by X plus the distance traveled by Y should be 100 miles. So 20T plus 100T by 3 should be 100. So taking the LCM, I would get 160T divided by 3 is equal to 100. So that's 300. 160T is 300. I'll cancel the zeros. So T would be 30 by 16. So 15 by 8 hours. So it would take X 15 by 8 hours to reach O. It would take Y 15 by 8 hours to reach O. What is the question asking me? How many miles had X traveled when it met train Y? So basically, I need to find out the distance. That's 20T. So 20 times 15 by 8. 4 2s are, 4 5s are. That's 75 by 2, which is 37.5. That is my answer. Right? You could have created your equations via the distance as well. Somebody asked me previously, right? You could have created your equations via the distance as well, guys. Okay. The distance traveled by x plus the distance traveled by y should be equal to 100 is what I use. I defined taking the constant is actually easy for me, right? The time is constant. The time that x would take to reach O and the time that y would take to reach O would be exactly the same. Got it? We'll come to average. We'll come to relative speed, Karthik. I have not touched relative speed yet. What you're mentioning there is t divided by a plus b is the relative speed. We'll come to that. Okay, I have not explained what relative speed is. Ideally, solving such questions using relative speed is the faster approach. But I'm just integrating, right? I'm giving you the algebra approach first. I'm trying to cater to multiple kinds of students, right? I've tutored many. Some students are very good at setting algebra, some students are good at visualization, some students are good at both, right? I'm working with the algebra bit first. I'll explain what relative speed is. I will show you how to work with it. That's more visual in nature. It cuts out the lot of algebra that you have to work with. I again followed the same approach. The only thing that I integrated when I have a question where two bodies move is the visual aspect, is the graphical representation. I drew it out, made my table, I tried to figure out what is constant, and I tried to build my equation from distance and time. Got it? Guys, if you ask me, can we try out eliminating the answer choices? Of course you can, right? But what if the question asks you what is the sum of the distances of x and y, or they ask you what is the total time taken? Then you're not going to be able to use your answer choices. What you're telling me here that I want to use my answer choices as a first mode of attack, it's an alternative process that will only work for a handful of questions. That will depend on what the question is asking you. I can definitely, after eliminating C, D, and E, I showed you that I can eliminate C, D, and E. I could have taken 40 and I could have taken 37.5. I would have started with 40, put in all the data and see if all the working would ratify with the information that is given to me. And I can eliminate. But remember, all that alternative strategies and alternative shortcuts, those are very few and far between. You'll only find it applicable on certain kinds of questions. Next questions I pick, you will not be able to use your answer choices. But yes, that is a valid possibility. That is something you should use when you get stuck on a question. Okay, using your answer choices, putting a value and working your way through, all of those are alternative processes that you should explore in your practice phase, but don't utilize it at the cost of understanding the structure and concepts, because in a data sufficiency question you will not have answer choices to break down. Correct? That is why I don't endorse the process of looking at working with answer choices from the outset. It is something that you should keep as an alternative option open, available, if the conventional option fails. Learn to understand the concepts first. Got it? I could have easily done this and cancelled it out and then used my answer choices and worked. That would have been the most ideal. But I'm focusing on the bigger picture here. Okay? Focusing on setting things up. So this is one way. Okay with this, guys? I'm okay with the algebra process. What did I do in the two bodies moving? I just added the graphical representation. I drew things out, I still put the table, and I still created my equations out of it. Okay, not deviating. But if you're open now to bring in visualization and depend upon visualization to solve and get a good understanding of another concept called relative speed, you can reduce the time that you take to solve these questions. So I saw somebody said they used the formula T is equal to D by A plus B. That's again not a good way to learn the concept of relative speed. Rather than just learning the formula and D by A plus B, learn what relative speed actually is. So now I'm going to explain what exactly relative speed is and how you can work with questions where two bodies move from a visual aspect as well. When two bodies move, it always gives you the option of working with relative speed. Okay. So let's first understand what relative speed actually is. Relative speed is the cumulative speed of two bodies moving simultaneously the key word here is simultaneously with respect to each other in a particular direction. Again, I'm going to underline particular direction. I'm underlining the keywords here. What is relative speed? It's the cumulative speed of two bodies moving simultaneously with respect to each other in a particular direction. If the two bodies are moving towards each other, we always add the speeds up. Now you can ask me why. I will show it to you logically, okay? And if the two bodies are moving in the same direction, we subtract the speeds. Correct? Guys, you have a problem with the font size? Is it too small for you? Because I think my writing is also very cursive and large. Anybody else has a problem with the font size? Guys, if you're using a mobile, then maybe I would say put it on full screen mode because I'm writing it pretty big. Guys, anybody who's finding it hard to read what I'm writing? The font size, I can understand I can't change my writing, but the font size is fine. Okay. So when you're moving towards each other, add the speeds. When you're going in the same direction, subtract the speeds. Why? We will look at it in a visual explanation after this. When you're working with relative speed, it is important that you have simultaneous motion between the objects. You cannot use the relative speed if you do not have simultaneous motion. Now you can ask me, what if one person travels and the other person is at rest, and then after some time both people start moving? No problem. I will visualize it like a real life question. If one person travels when the other person is at rest, I can find out the distance that the first person has traveled when the other person is at rest. Now for the remaining distance, they are going to travel simultaneously with respect to each other. So remember, if you're making use of the relative speed, you have to have the bodies moving simultaneously. Now link it back to the graphical representation that I put in. I said when you're representing things graphically, always try to draw the graph, set up the graph such that it represents points from which the two bodies move simultaneously with respect to each other. That's the reason why, so that you bring in that option of using relative speed. One more thing you have to understand is, what does this relative speed give you? This relative speed, I'm going to call it RS, along with the gap distance. I'm going to write all of these, but I'm going to explain it visually for you to understand it better. What is this gap distance? The gap distance is the distance between the two bodies just before they start moving simultaneously with respect to each other. Just before they start moving simultaneously, it is the distance between the two bodies. So this relative speed, the cumulative speed, along with this gap distance, what do they give me? Remember, speed is equal to distance by time. Same logic, relative speed is equal to, speed becomes relative speed here. The distance becomes the gap distance. So divided by time. What is that time that you get here? The time that you end up getting if you use a concept of relative speed is the constant time. What does relative speed give me? This is something you have to imprint very quickly in your head. Relative speed always gives me the constant time that it will take for the two bodies to meet each other at a particular point, at that meeting point. So, what do we get from relative speed? Yes, you can have them diverging as well. If they are diverging, you would still add the speeds up, right? If one, there's an example that I'll pick. If one person, think about it, right? When I visualize it, you'll understand it better. When they're going, so diverging, what he means for people who are reading the chat window, diverging means they are moving from a particular point in opposite directions. So even if the bodies are moving in opposite directions, it depends whether they are in the form of a circle or whether on the linear arrangement or a linear format, you would still add the speeds. I'll show you why in a visual representation, right? So what does relative speed give me? It gives me the constant time it takes for the two bodies to meet each other. I get that constant time that it will take for them to meet. And from that constant time, I can find everything else. So what I want you all to understand is this. What is the relative speed first? It is the cumulative speed of two bodies moving simultaneously. I need simultaneous motion with respect to each other in a particular direction. Direction is also important. If the two bodies are moving towards each other, add the speeds. But if the two bodies are moving in the same direction, subtract the speeds. I personally would always use relative speeds for towards and the same. Because relative speed works best when bodies are meeting each other. If bodies are moving away from each other, diverging, like somebody said, I would not make use of relative speed because they're never going to meet unless, like I said, they are traveling around a circular track. Okay. And I don't think, now with geometry being removed, that they give you a circular track. If they give you a circular track, then obviously they will mention what the circumference of a circle is, the formula in brackets at the end of the question. Okay. I would always use relative speed when I have a question where bodies are meeting each other. And that's only possible when the two bodies are moving towards each other or in the same direction. All right. And what does relative speed give me? Relative speed along with the gap distance. What is that gap distance? The distance between the two bodies before they start moving simultaneously. What does these two give me? They give me the constant time that it would take for the two bodies to meet each other. Right? So let's understand these points now from a visual aspect. Okay, I just don't want you to mug it up or rote learn it. That when you have bodies towards each other, moving towards each other, you add, and in the same direction you subtract. Let's understand it visually. Okay. So let's take an example where two bodies are moving towards each other. Let me draw out a scenario. Okay. Let me draw out a scenario and use that as an example. Let's say we have A and we have B. A is traveling at the speed of 20 miles per hour. Let's say 30 miles per hour for A. And B is traveling at the speed of 20 miles per hour. And let's say the distance, the gap distance between them when they started moving is 200 miles. And let's say they're moving simultaneously towards each other. I put the directions, the arrows towards each other. So I'll mark a logical meeting point. I told you when I draw a graph, I'll put in all that data. I'll put in the directions and I'll put a logical meeting point. Clearly A is traveling faster than B, right? So they have to meet closer to B. So let me call that O. That's my logical meeting point. Now let's, instead of going ahead and solving the math, let's visualize this journey in intervals of 1 hour each. Okay. Let's visualize it in terms of 1 hour intervals. Now, since both of them are moving simultaneously, A starts moving towards O, B starts moving towards O. So in 1 hour, A would travel 30 miles. And in that same 1 hour, B will travel 20 miles. You see, in that same 1 hour, B would travel 20 miles. So cumulatively, what is the total distance traveled by A and B together in that 1 hour? It's 30 plus 20, which is 50 miles per hour. It's 50 miles. So cumulatively, both of them have traveled 50 miles in 1 hour. That's why the relative speed is the addition of the two speeds when the two bodies are moving towards each other, right? Because 30 plus 20, that's 50 covered by both. So we say the relative speed is 50 miles per hour. That's why we add the speeds up. But let's again continue visualizing it in intervals of 1 hour. So 30, 20, 50 miles is covered. In the next 1 hour, A would cover another 30, B would cover another 20. So another 50 is covered, a total of 100 miles is covered. Again, in the next 1 hour, A would travel another 30, B would travel another 20, another 50 is covered. So total distance of 150 is covered. And finally, in the last 1 hour, A would travel the last 30 and B would travel the last 20. So that's 200 miles covered. And if 200 miles is covered by both, that means they've met each other at this meeting point O. So how many intervals of 1 hour did it take for A to reach O and B to reach O? 1, 2, 3, 4. It took 4 hours. It took B also 4 hours. That's why I said, right? What does relative speed give me? It gives me the constant time that it would take for the two bodies to meet each other at this point. Got this? So now how would I put this in an algebraic format? I know my relative speed is the addition of the two speeds here. Why? Because cumulatively they're traveling 50 miles per hour. And what was the gap distance between them when they started to move simultaneously? The gap distance between them was 200 miles. So using the formula, speed is equal to distance by time, I can find out the constant time. Time is equal to distance divided by relative speed. That's 200 divided by 50, which is 4 hours. Now, what does that 4 hours represent? It is that constant time it would take for A to reach O and B to reach O. And from this constant time, I can find out what is the distance that A has covered and what is the distance that B has covered individually up to the meeting point. A would have covered 30 times 4. You see, 30 times 4, 120 miles. And B would have covered 20 times 4, that is 80 miles. You see, I get all pieces of information there. And this is what I want you to understand. Why you add and what is the relevance of relative speed? It gives you the constant time it would take for the two bodies to meet. Now, what if the two bodies are moving in the same direction? Let's again create a scenario for it. If the two bodies are moving in the same direction, again, let's say we have A. A is again traveling at 30 miles per hour. And let's say we have B. B is traveling at 20 miles per hour. And let's say the gap between them is 100 miles. And this time, they both start simultaneously moving in the same direction. Obviously, A is traveling faster because he has to catch up to B. So they both are moving in the same direction. A will catch up to B at some point. So visualize it. Since A is traveling faster than B, both of them are moving. If both of them are moving, A would catch up to B slowly. Like it's like a Formula One race happening, right? You have the McLaren here, and then you have the Ferrari chasing them, right? Maybe old school, a Mika Hakkinen and a Michael Schumacher, right? And you have Michael Schumacher chasing Mika Hakkinen. Michael Schumacher is traveling faster than Mika Hakkinen. So obviously they both are going to meet at some point here where the gap is going to reduce slowly, right? So this is going to be my meeting point. I'm going to call it O. I'm always going to put in a logical meeting point. Now again, let's understand this movement in terms of intervals of 1 hour. Okay. I'm going to make like a table of sorts for you to understand better. So I have A and B, and this is at the start. At the start, A is at 0. A is at the start. B already is 100 miles ahead of A. So the gap distance between them is 100 miles. B starts from point 100. Now let's visualize it in intervals of 1 hour. After 1 hour, A would go from 0 to 30. A would go from here to here. B would go from here to here. And B will go from 100 to 120 because B is traveling at 20 miles per hour. That's 120 miles. This is 30 miles. So after 1 hour, look at what has happened to the gap. The gap between them has reduced to 90. And why has the gap between them reduced to 90? Because A is traveling at a speed that is 10 miles per hour faster than B. A is 10 miles per hour faster than B. So A travels that extra 10 miles in that 1 hour and catches up that 10 miles, that extra 10 miles. It uses that extra 10 miles to catch up to B. How do we get that 10 miles? If we subtract the two. That is why the relative speed here is always the difference between the two speeds. It's 10 miles per hour. Because A is traveling at a speed that is 10 miles faster than B. How am I getting the 10 miles faster? Subtraction. Got it? So if I continue doing this, think logically. If A is catching up to B at the rate of 10 miles every hour, that means every hour A catches up 10 miles. And the total distance that A has to catch up to B is 100 miles. So every hour if A catches up 10 miles, if the total distance to be caught up is 100 miles, then the time taken for A to catch up to B would be 10 hours, thinking logically. But if you want me to put it mathematically, the relative speed is 10 miles per hour. What was the gap distance between the two bodies? The gap distance between the two bodies is 100 miles when they start. And what does this give me? This gives me the constant time. That is 10 hours. What is that meaning of constant time? It will take A 10 hours to reach O. It will also take B the same 10 hours to reach O. So I know after 10 hours, A has caught up to B at this point, at the meeting point. A has made that gap distance from 100 to 0. So the constant time is 10 hours. So now I can use this constant time to figure out how much distance A has covered. A has covered 30 into 10, which is 300 miles. And B has covered 20 into 10, which is 200 miles. You see, A has covered 100 miles more than B, so has caught up to B. This is how we make use of relative speed. Okay? We always make use of relative speed on questions where bodies are going to meet each other at a particular point, right? Whether they are moving towards each other or in the same direction. This is something that you have to keep in mind. It's a more visual process of working, but I don't want you to rote learn it as a formula. I want you to understand it logically. Relative speed is the cumulative speed. Simultaneous motion requires direction. Towards means add, same direction means subtract. What does relative speed give me? Constant time that it takes for the two bodies to meet each other at a particular point. From that constant time, I can find everything else. So how do we make use of this concept onto that question that we just solved? You'll see how easy the entire question becomes, right? I'm going to now solve this using the concept of relative speed. And why can I use relative speed? Because the two bodies are meeting each other. They are moving with respect to each other simultaneously in a particular direction. I will still draw things out, right? What am I doing? I will still graphically represent the question. The algebra bit will change. Instead of forming that table and then putting in all the information and forming algebraic equations, I will now make use of relative speed. That is the switch I'm going to, that is the change I'm going to switch into. Two trains start simultaneously from opposite ends of a 100-mile route. Simultaneous movement already from the beginning. This is the 100-mile route. This is X, this is Y. They are moving simultaneously towards each other, right? On parallel tracks. Train X traveling at a constant rate completed the 100-mile trip in 5 hours. So the speed of X is 20 miles per hour. I'm directly writing that. And train Y completed the 100-mile trip in 3 hours. So the speed of Y is 100 by 3 miles per hour. And they are moving simultaneously towards each other. I'll put a logical meeting point. This is my logical meeting point. O obviously closer to X because Y is traveling faster. I've set up everything. What is my question asking me? The question is asking me the distance that X takes to reach O. Immediately I see that they're moving simultaneously. I can make use of the relative speed. What is the relative speed here? They are moving simultaneously from their initial start points and they're moving towards each other. So the relative speed should be 20 plus 100 by 3, which is going to be 160 by 3 miles per hour. And what is the gap distance that I'm starting with between them? What is the gap distance? What is the distance between the two bodies from which they start moving simultaneously? That is 100 miles. And what does the relative speed give me? It gives me the constant time it would take for the two bodies to meet each other at this point. Oh, so time is distance by speed. So 100 divided by 160 by 3. So the 3 goes on top. This goes to 5 to 8. That gives me 15 by 8 hours. What is the meaning of this 15 by 8 hours? It takes, that's the constant time it would take the two bodies to meet each other. It takes X 15 by 8 hours to reach O. It takes Y 15 by 8 hours to reach O. Right? So what is the distance that X has to travel is what I have to figure out. So the distance that X has to travel should be the speed of X into the time of X. What is the speed of X? 20. What is the time of X? 15 by 8. So 4 2s are, 4 5s are, that's 75 by 2, which is 37.5. This would be our answer. Done. Got it? This is the relative speed process of working. Cuts out a lot of algebra, but is more visual in nature. You'll have to draw it out. You'll have to understand what relative speed is very carefully before you're going to make use of this process. Make sense? Any doubts on this, guys? I'm setting up all the processes up front. I'm setting all the structures up front. So as we go forward, the questions that we pick, I will utilize both the processes. Okay, especially with two bodies moving, I will set it up algebraically as well. I will also set it up using relative speed. Right? Explore. I would say you also explore both the processes of working. Any doubts here? I'll pause. Heavy information to take in. So I'll pause. Any doubts? Please clarify it now. No? Then can we go into another question? Right? Okay. Another official one. Give it a shot. So remember, guys, with two bodies moving and they're meeting at some point, you have a choice. You can either go conventional using the algebra process of visualizing, setting up the table, solving the same as one body moving, or you can use the relative speed concept if you understood that, right? Explore both. Okay. I'll give you a 5 minute break after this session. Um, for those who've already sat for 2.5 hours, guys, you're free to drop off if you want. Right? Like I said, the recording is always going to be available. It will take me another good part of an hour, 15 minutes. Okay, more. It is an hour and a half, I would say, on the safe side, to finish everything else that I have to discuss. Okay, you can start putting your answers in the chat window, please. And tell me also, attach what process did you use? Did you go with the algebra process of setting things up using the table? Did you go with relative speed? Okay. So you should not make silly mistakes, okay? Shlok, if you're using decimals, be careful of converting decimals into hours and minutes, okay? Just my advice. So if you've got, just check it again. Okay, Taibu, if you use algebra, why don't you explore the relative speed process as well? Guys, what I'm trying to inculcate in you, right, is a process of how practice needs to be done at the learning phase. When you're learning a topic, don't try to solve questions with a perspective of getting to an answer. Okay, explore, see what all processes are available. I've given you two, right? So if you got to an answer, don't just sit and say, okay, I've got to my answer. Try to explore the other. Decision making builds with that. Okay, the very fact that you're trying alternative processes helps with decision making. It also helps with giving you an alternative to shift into if you get stuck somewhere. I'll give you another minute and then we'll go into a discussion. Even for people not getting to an answer, type in the chat window, where are you stuck? Okay, if you can do that, I can cater to that in my explanation. For those who give me D, Karthik and Amit, can you also put in, did you use relative speed or did you use algebra or both? Okay. All right. Let's discuss. The first thing that I would do in the structures that I've set up, whether it's relative speed or whether it is the algebra process, I am going to graphically represent my question. I'm going to draw it out. Right? Mary passed a certain gas station on a highway while traveling west at a constant speed of 50 miles per hour. Okay, I know I have to travel west, but I'll just use the right hand part of my screen. So Mary is here, right? Let's say she's traveling east instead of west. So she passed a certain gas station. So let's say this is a gas station. And she travels at a constant speed of 50 miles per hour. Okay, she passed this gas station moving at 50 miles per hour. 15 minutes later, so I'll pause there. So, what is happening in that 15 minutes? Paul comes to the gas station. Remember, my gas station is my reference point. I'm not worried about how much they traveled, the hot speed they traveled before the gas station. Gas station is my reference point. So 15 minutes later, Paul comes here. But where is Mary? Mary has already traveled for that 15 minutes. So what I can do, I know Mary's speed. Mary should be somewhere here. I know Mary's speed is 50 miles per hour. So I can pause there. I can find out the distance that Mary has traveled in that 15 minutes. Right? So what will be the distance that Mary has traveled in that 15 minutes? Distance is equal to speed into time. That's 50 into 15 by 60. Right? That's 1 by 4. That's 5. 4 ones are. That's 12.5. Right? So that's 12.5 miles. That's the gap between Peter, Paul, and Mary. Paul passed the same gas station while traveling west at a constant speed of 60 miles per hour. That's what I have. Okay. If both drivers maintain their speeds, so they're not changing their speeds, and both remained on the highway for at least 2 hours, so for the next 2 hours, there's no stoppages. How long after he passed the gas station did Paul catch up with Mary? So they need to, if they ask me to find the time that Paul takes to catch up to Mary. So I'll divide this into two parts. On one side, I will use the conventional process of algebra by setting up my table, setting up my equations and solving. And on the other, I will work with relative speed. So what do I have? I have distance, I have speed, I have time, I have Mary, I have Paul. Mary is traveling at 50, Paul is traveling at 60. Now, I know they're going to meet at this point. They're going to meet somewhere here. I'm going to call that logical meeting point as O. Now, I'm going to ask myself, okay, since Paul and Mary are starting to move simultaneously with respect to each other from the gas station here, Paul is moving, Mary is moving from here. The time, what is constant here? The time that Mary takes to go from here to O should be the same time that Paul takes to go from P to O. That is the only way they can meet each other, right? I want Paul to catch up to Mary, right? So they're going to catch up. Paul is going to catch up at this point, and they're both moving simultaneously. Paul obviously moving faster, right? This is an official, GMAT question, right? This is an official guide question. Now, the time that Paul will take to reach O is the same that the time that Mary will take to reach O. The time is constant there, right? So I'm going to keep the time as t. So the distance that Mary travels is 50t. So this distance is 50t. And the distance that Paul travels, that's this entire distance, should be 60t. So if this entire distance is going to be 60t and this distance is 50t, I know that 60t minus 50t should be equal to 12.5. So 10t is equal to 12.5. T is 1.25 hours. So 1.25 hours, the answers are in hours and minutes. 1.25 hours, 0.25 hours is 1/4 of an hour, and 1/4 of an hour is 15 minutes. So it will be 1 hour, 15 minutes. Right? That would be your answer. You could have also done this. Instead of keeping the time constant, you could have done with distance, right? You could have said Mary takes 15 minutes more than Paul to travel. So I can keep the time for Mary as t plus 1 by 4. I can keep the time for Paul as t. I can find out their distances, and I know the total distance. I know the distance between them is 12.5. I could have created an equation like that as well. I use the simplest process I can. I know the time that Mary takes to travel from here to O should be the same time that Paul takes to travel from P to O. I use that to set up my algebra. Slightly more convoluted, and it requires that visual bit of figuring out that the time is constant. It's like a policeman and a thief, right? Both of them are starting to move at 12:30, right? And the Paul catches up to Mary at 3:30. So Mary is still traveling for 3 hours. Paul is still traveling for 3 hours, right? Obviously, Paul is traveling faster. So that is why time was constant. Understood? That is one process to work. But the relative speed process would have been much simpler. And I prefer using relative speed on these questions because it cuts out a lot of algebra for me, right? I don't need to sit and make all of these equations, find out what is constant, and so on. I know they are moving simultaneously with respect to each other. What do I require for relative speed? I require simultaneous motion. I require the direction in which they are moving. And I require the gap distance between them when they start moving simultaneously. What will I get from relative speed? The constant time. So immediately I'll say they both are moving in the same direction. So what should be my relative speed? It should be the difference of speeds, that is 10 miles per hour. What is the gap distance between them when they started moving simultaneously? 12.5 miles. So what is the constant time that they will take to meet each other at that point O? Time is equal to gap distance divided by the relative speed. That's 1.25 hours. 1.25 hours is 1/4 of an hour, which is 1 hour and 15 minutes. You see, just gets rid of all that calculations. And I get to my answer way quicker. Right? So if you understand the concept of relative speed, it actually helps simplifying the question for you in a much, much better way. Right? Anytime you see that bodies are meeting at each other at some point, they're moving towards each other in the same direction, always prefer to use relative speed. In any other scenario, you always have the option to revert to the conventional process of setting up algebraic equations. Yes, you could have also done 60 into t minus 15 by 60 is equal to 50t, or creating your equation via the distance. Absolutely okay to do that as well, right? Absolutely okay to do that. Just one small change, Ramon. I wouldn't write it as t minus 15. I'll have to write it as t minus 15 by 60 because I have to maintain all the units across a common. I have to maintain all the times across a common unit, right? So if you didn't get it with that equation, you have not put the, you're not changed that 15 minutes to hours. Got it? So you'd have to write it as 15 by 60. So that 15 would change to t minus 1 by 4. Make sense? Come on. So you created your equations via the distance, totally fine. Guys, whatever you do, right? If you're going the conventional process, either you create your equations via the distance or you create your equations via your time. Alright, just ensure that you make the units across a common factor, right? The units have to be the same. So people who written t minus 15, guys, I can't do that because they're giving me the speeds in miles per hour and 50 miles and 60 miles per hour. So I need to convert the times into hours. So 15 by 60 is what you should do, right? For those who didn't get it by using the time as t minus 15, that is your mistake. But you see, relative speed is something that you should try and explore because it just cuts out a lot of these equations. But if you get an understanding of the equations, you always have the opportunity to set things up nicely. Got it? All right. So let's take a break here at this point. I'm going to give you an 8-minute break, and then we'll move into the last phase of our discussion. We'll discuss a couple of more questions. I'm going to make it more difficult, like I said. Stick to the same process, and then we'll also explore some data sufficiency questions again, where I'll not deviate from the process. Okay. If you have a catch up and pass, if you want me to use relative speed, okay, let's look at this way. Somebody asked me, what do you do for a catch up and pass, right? So if I want them to catch up to each other, I know I can find it out using the constant time, right? If they have to pass and you want to put a gap between them, that would be my gap distance now, right? So the relative speed would still be the difference of two speeds. The gap would be the gap that you want to put between them after they meet each other and pass. And I can find out the constant time it would take to put that gap. Makes sense? Suppose they meet each other at this point, right? They meet each other at this point, and then you want them to continue their journey and you want to put a gap distance of 40 miles per hour. You want to put a gap distance of 40 miles, right? So this is your question. They have met each other at this point O. They continue their journey, and you want the gap between them now to be 40 miles. So what will I say? They're continuing the journey, so the relative speed will still be 60 minus 50, that is 10 miles per hour. The gap distance you want to put is 40 miles. So what is the constant time that it will take to put that 40 miles gap? 4 hours. So they keep traveling again for 4 more hours after they meet to put that gap distance. Got it? Simple. I just have to visualize it, right? Nothing different. Nothing changes. I would still use relative speed. I want to know what gap I want to put between them after they meet and after they pass each other. I can find out the constant time, right? Or they'll ask me the reverse. They'll say that they catch up to each other and they move forward again for another 2 hours. So if they're moving forward for another 2 hours, I know the constant time now. They've given me the constant time of 2 hours. I know what the relative speed is. It's the difference between the speeds. I can use the relative speed and the constant time to find out the distance between the two. Simple, right? Answers your question, Kadar? Kadrisa, I'm sorry if I'm pronouncing it wrong. Right? Does it answer your question? Right? I would still follow the same process. Nothing changes. Somebody asked me, are these really GMAT level questions? Guys, all the questions that I've picked so far are actual official retired GMAT questions. Okay, I've not even picked a question from GMAT Club. All of them that I've picked up are official retired GMAT questions. You can go and search for it on GMAT Club as well. They are OG linked questions. Yes. Guys, we have 5 minutes. So if you want to ask me something, I'm giving a break here just for you to use the restroom or log off or drink some water. Yeah, 4 minutes. So you want to ask me something, please ask that now itself. It will go on for maybe another hour, 15 minutes. Right? I don't think I'll be able to finish all the questions that I have, but I always bring in extra questions. So the questions that I skip, you'll always get in the PDF of the slides and also the explanations of the questions that I don't discuss during the session. Okay. It will go for another hour, 15 minutes. Okay. After that. Another 3 minutes, guys, and we start again. Like I said, if you want to ask me something, you can ping in the chat window. For those asking to reach out to me, guys, you can reach out to me via LinkedIn or via my email ID. Sure, right? If you're not able to find a explanation that is satisfactory on GMAT Club, you can always reach out to me, guys. I mean, I do have a busy schedule, so I may take some time to respond. I'm still, in the process of catching up on my email. I'm 2 days behind, so I will respond, but it may take me some time to do so. Okay. Any other GMAT topic is planned? We have one more topic, right? And that would be the concept of absolute values. That would be the last topic that I discuss before we take a pause. Um, so that's the plan, right? Maybe in 2 or 3 weeks of time, that would be the last topic. Last minute. No, practicing more questions, just randomly practicing is not going to get you at better decision making. Spending time on brainstorming on a question, right? Looking at different processes of working and doing it on a good set of questions will make your decisions better. Okay, so when you see a question, you know exactly how to approach it. Why? Because you've done that groundwork and studied questions, looked at patterns. You've done your due diligence on that. Understood? So don't say the normally I find this with a lot of test takers. They think that the cure all for everything is more practice. So remember, guys, it's not only just practice, right? I mean, if a person takes 100 questions of a topic and brainstorms on those 100, looking at different ways of working, right? Understanding the structures well, that's much better prep than working with 400, 500 questions of that topic, but not focusing on decision making and reasoning. Okay, the only way to improve decision making and reasoning and observation is for you to slow down and brainstorm on questions. Got it? Like how I'm doing here, right? You see, I never in a session get into quickly solving a question, getting to an answer and moving on, right? That doesn't make sense. It's been 2 hours, more than 2 hours, right? And you're still at question 7, right? So how I work with a question is exactly how I envision my test takers to do on their practice as well. All right. Okay. So let's continue. I'm going to make this a little more harder. Let's try question 8. Again, an official guide question. Try it out. Give it a shot. Okay, you can start typing your answers in the chat window, please. A minute more, then we'll discuss. Okay, let's have it. Let's discuss on this, please. Now, a hiker walking at a constant rate of 4 miles per hour is passed by a cyclist traveling in the same direction along the same path at a constant rate of 20 miles per hour. So I'm imagining a scenario. I'm the hiker, I'm walking in the woods, and I'm traveling at the rate of 4 miles per hour. And suddenly, a cyclist passes me, traveling at a rate of 20 miles per hour. The cyclist stops to wait for the hiker 5 minutes after passing us. So let me visualize this. What's happening? After the cyclist passes me, the cyclist continues moving for the next 5 minutes. Now, in that next 5 minutes, even the hiker is moving 5 minutes for 5 minutes. And then what happens after that 5 minutes? The cyclist stops to wait for the hiker, while the hiker continues to walk at her constant rate. So I continue to walk at my constant rate. So I'm going to visualize this. I see I'm the hiker, I'm walking. I have the cyclist pass me. We both move for 5 minutes, right? We both move for 5 minutes. And after 5 minutes, the cyclist stops. Obviously, the cyclist is ahead. And the hiker continues to move. And the questions ask me how many minutes must the cyclist wait until the hiker catches up. So let me first visualize this, right? This is the start point. This was the hiker first. The cyclist passes the hiker and they both travel for 5 minutes. So if they both travel for 5 minutes, the hiker moves from here to here in 5 minutes, and the cyclist moves, let's say, from here to here in 5 minutes. That's the cyclist. So, first thing I can do is I can find out, since I know the individual speeds at which both the hiker and the cyclist are traveling, I can find out their total distances that they have traveled in that 5 minutes, right? I can find out the distances. So the distance, this is the easiest process to work. The distance traveled by the hiker would be the speed of the hiker into the time. That will be 5 by 60 hours. That's 4 into 5 by 60. 20 by 60, that is 1 by 3 miles. This is the distance that the hiker travels in that 5 minutes. You see, I'm only using my graphical representation at this point. In that same 5 minutes, the distance traveled by the cyclist is going to be what? It's going to be the speed of the cyclist into the time, that is 5 by 60. So that's 20 into 5 by 60. That is 5 by 3 miles. So the cyclist has traveled from here to here. That is 5 by 3 miles. So if the distance from this H, the first H here to C is 5 by 3, and this distance is 1 by 3, then this distance, the gap distance now when the cyclist stops, would be 4 by 3 miles. That would be the gap between the two. And I know the cyclist is going to stop there. Cyclist is not moving at all. So I don't need to worry about relative speed. All I have to figure out is how much time does the hiker take to cover that distance and reach the cyclist. So I know the distance that the hiker has to travel now is 4 by 3 miles. I know the speed of the hiker also, which is 4 miles per hour. So what will the time the hiker takes to catch up to C? Time is distance by speed, that's 4 by 3. Distance divided by speed, right? So that is 4 by 3 into 1 by 3, 1 by 4, that is 1 by 3 hours. And what is 1 by 3 hours? 1 by 3 into 60, and that would be 20 minutes. That is my answer. That's the best way to work. Visualizing the question from that graphical representation and putting the pieces together. This is a good process to work. You can make use of relative speed as well. You can make use of equations as well. If you say, Aditya, I want to use the table. It's not easy for me to visualize this. I want to use the table. So let's see how can you use the table as well. If I'm using the table, I still have to represent the question graphically, right? So I have the hiker moves from here to here in the 5 minutes, and the cyclist moves from the start point to here in 5 minutes. So I'm going to put in the data, DST. I have the hiker, I have the cyclist. I know the speed of the hiker is 4 miles per hour. The speed of the cyclist is 20 miles per hour. What is the time that the hiker takes? The time that the hiker takes to travel, visualize it. The time the hiker takes to travel will be this first 5 minutes to come to this point, and then the remaining time to catch up to C. So I'll say it's going to be 5 by 60, 5 minutes divided by 60, plus that extra time T to catch up to C. And what is the time that the cyclist will take to reach this point? He will just take 5 minutes to reach that point. So this will directly be 5 by 60 hours. So now I can find the distance. What will be the distance? Here it will be 4 into 5 by 60 plus T if you want to go algebraic in nature. And this will be 20 into 5 by 60. That will be 5 by 3. And what do I know now? I know that the total distance that the hiker traveled and the total distance that the cyclist has traveled are exactly the same. The distance is the same from here to here and here to here for both. So 4 into 5 by 60 plus T is equal to 5 by 3. And now I can solve for this, right? I can open up the brackets, so that will become 20 by 60. That's 1 by 3 plus 4T is 5 by 3. So 4T is equal to 4 by 3. So T is equal to 1 by 3 hours. 1 by 3 hours is 20 minutes. This is another formulaic algebraic process of working, right? For those who went this route. The better thing to do was what I did. Find the distance that the hiker travels in 5 minutes. Find the distance that the cyclist travels in that 5 minutes. The difference should be the gap. And that gap is what the hiker has to cover to catch up to C. I don't even have to use the relative speed here, because for the hiker to catch up to C, the cyclist is already at rest. So it's only the distance that is between them that the hiker has to catch up at the speed of 4, traveling at the speed of 4 miles per hour. Make sense? So that's why I said, right, going with the question visually and using your visual representation is a lot more beneficial, because it cuts out a lot of algebra. But you can still work with it algebraically. What did I do here in algebra? I put in my speeds and I asked myself, what is the time that the hiker will take from going from here to here? The initial 5 minutes plus that time he'll take to catch up to C. What is the time that the cyclist will take? 5 by 60. And I know that the distance that they both will cover will be exactly the same. Absolutely. Somebody said you can find the relative speed. What is the relative speed here? Since they both at the beginning, as soon as the cyclist passes the hiker, I know both the hiker and the cyclist are moving simultaneously. So I can find out the relative speed here. What is the relative speed? The relative speed would be the difference between the two speeds. That's 20 minus 4, which is 16 miles per hour. Right? And I know that they're traveling for a constant time of 5 minutes. That's 5 by 60 hours. So I can find out the gap distance between them. This is what somebody said in the chat window. I can use relative speed as well. What is the gap distance? The relative speed into the constant time. Right? So 5 ones are, 5 ones are, 12s are, that is 4 by 3. So you see, you got the gap distance as 4 by 3 miles. So this is the gap now between them. You got that directly by using relative speed. That's also a very good way of working. You see, I'm giving you, this is how you need to work with the speed distance time question, right? Arm yourself with multiple approaches of working. The algebraic approach, the most fundamental approach, you can always depend on it, but you'll have to set up your algebra right. The visual approach and integrate it with the relative speed. You can work with it. See, once I get the gap distance, I know the hiker has to travel this 4 by 3 miles, traveling at 4 miles per hour. I would get the 20 directly. Got it? So this is what you'll have to do, okay, in this entire topic. I've put in all the content that is required for you to work with such questions, right? So now you'll see as we go further, even we'll look at a couple of data sufficiency examples as well. I'm not going to deviate from the process, okay? So the next question is a slightly difficult one, but if you're able to understand the relative speed and apply it, it would be beneficial. You can also use the process of setting up algebra and equations. Okay. Now this is a GMAT club question, and this is classified at a 700 level. Give it a shot. Okay, you can start typing your answers in the chat window, please. It's a tough one because it requires a two-level process of thinking. Like I said, any one process, you want to use the letter speed, use it. You want to go with equations, use it. But either way, you have to visualize the question, graphically represent the movement, and understand the question very carefully. For those stuck at a particular point, type in where you're stuck as well. Guys, remember the group is also moving, right? Visualize the question. That is why questions become slightly harder, because when you read it, you'll have to visualize it like a real life scenario. The group is not stationary, right? It's a moving walkway, right? So the group is moving along with the walkway as well. Bill is moving with the walkway and he's walking as well, right? That's why he's moving at a faster pace. It's like, I think, what the one of them, Delhi or Mumbai airports, you have those travelators, right, between gates. It's like that, right? So some people on the travelator would just stand and allow the travelator to move. So you're moving with the speed of the travelator. Some people would walk on the travelator, right? Because they want to quickly reach to their gates, right? If you visualize it like a real life scenario, you'll understand what I mean. So people have given me C as the answer. High chance that you would have kept the group stationary. You wouldn't have considered that they are moving as well. Yes? Good. Somebody's fixed it as well. Okay. So let's discuss. It's very important, like I said, do the first bit right. If you do the first bit right, everything falls into place. Read, process, visualize, organize. The moving walkway is a 300-foot long conveyor belt that moves continuously at 3 feet per second. So I visualize a big walkway, it's continuously moving. It's a conveyor belt. It's continuously moving at 3 feet per second and it's 300-foot long. When Bill steps on the walkway, a group of people that are also in the walkway stand 120 feet in front of him. So I'm going to also, when I'm organizing my information here in a question where two bodies move, I'll need to graphically represent my information first. Right? So this is my entire moving walkway. That is my 300-foot long conveyor belt. And it's moving continuously at 3 feet per second. Bill steps on the walkway. So Bill is here. A group of people that are also on the walkway stand 120 feet in front of him. This is 120 feet. He walks towards the group at a combined rate, including both walkway and foot speed, of 6 feet per second. The group is still moving at 3 feet per second. It's a continuously moving walkway, right? So the group is not stationary. The group is also moving. Reaches the group, he walks, he reaches the group, and then remains stationary until the walkway ends. So, since both of them are moving in the same direction, Bill is obviously moving faster. He's going to catch up to the group first. Let's call that O. So, he's going to catch up to the group at this point. And then he remains stationary. He travels with the group from this point until the walkway ends. So, this is the end of the walkway. Right? Now, what else do I have? What is Bill's average rate of movement for a strip along the moving walkway? So I need the average speed. For average speed, I need the total distance traveled by Bill divided by the total time. So the first thing I know that Bill is going to catch up to that group. Right? So either I can set it up using equations. I'll say distance, speed, time. What do I have? I have Bill, I have the group, 6 feet per second, 3 feet per second. And I know the time that Bill will take to reach this meeting point O will be the same as the time that the group takes to reach this point O. So I can keep the time as constant, T. So the distance traveled by Bill, this entire distance should be 6T. And this distance traveled by the group should be 3T. So if this is 3T and this entire distance is 6T, then I know that 60 minus 3T is equal to 120 feet. So 3T is equal to 120. T would be 40 seconds. So it takes Bill 40 seconds to reach O. It takes the group 40 seconds to reach O. Right? So if it takes the group 40 seconds, if it takes Bill 40 seconds to reach O, then the total distance traveled by Bill will be 240 feet. And the total distance traveled by the group will be 120 feet. So the group is going to travel another 120 feet here. And Bill is going to travel the entire 240 feet. And they meet each other at this point. Now what does Bill do after he reaches the group? He stands and he moves along with the walkway towards the end. So now both Bill and the group are moving at 3 feet per second. And what is the remaining distance that they both have to cover? 240. So this has to be 60 feet since the entire distance is 300. So the distance now is 60 feet. The speed that they both are moving at is 3 feet per second. So the time that they will take to cover that 60 feet is 20 seconds. I've got that as well. I need Bill's average rate of movement for a strip along the moving walkway. So his average speed will be the total distance that Bill has covered, that is the entire 300 feet, divided by the total time that Bill has taken. So Bill has taken 40 seconds to reach O and then 20 seconds to go to the end. So 60 seconds. That will be 5 foot per second. That will be my answer. That's the conventional way of setting things up using the table. But let's say you didn't want to go this. You said, Aditya, I want to explore the visual aspect of using relative speed. Then what would I do? I would use the same process, but I wouldn't go with forming of this table. I would look at relative speed and I would use the relative speed and the gap distance to my advantage, at least to find out at what point are they going to meet each other, right? So what can I do here? I know Bill is traveling at 6 feet per second. The group is traveling at 3 feet per second. There's a gap distance of 120 feet between them. I'm going to remove everything else. And the entire walkway is 300 foot. I have all that information given to me. So the first thing I'm going to do is I need to find out how much time, what is the constant time it will take for Bill to reach that group. So what is the relative speed here? Since they're moving simultaneously in the same direction, the relative speed is going to be 6 minus 3, which is 3 foot per second. The gap distance between them is 120 feet. So the constant time that they will take to meet each other at this point O is 120 by 3, which is 40 seconds. So it will take Bill 40 seconds to reach O. It will take the group 40 seconds to reach O. So what is the distance that the group will travel? 3 times 40, which is 120 foot. And the distance that Bill will travel is 6 times 40, which is 240. You see, 120 plus 120. So now Bill is at this point. So the remaining is 60 foot of distance. And I know the Bill and the group now are going to travel with the walkway, right? He's going to stop and travel with the group. And both of them are traveling at 3 feet per second. There's a distance of 60 feet. There's a speed of 3 foot per second. I don't need to use the relative speed here because there's only one object, that group, that is moving. So the time would be 20 seconds. So I know now the total time. I know the total distance. I can find out the average speed. That is total distance divided by total time. That will be 5 foot per second. Make sense? A tough one. But you see, this is how questions become tougher. They'll be more visual in nature. There'll be multiple concepts that are thrown in as well. Got it? Again, I solved it using equations. I solved it also using the concept of relative speed. Relative speed is more intuitive in nature. Got it? Tough question. This is how a hard question would look on this topic. Okay. So what we'll do is we'll look at a couple of data sufficiency questions as well from here on. And you'll see, even when I work with data sufficiency questions, I am not going to deviate from the process that I have set up. Okay. It's just that in a data sufficiency question, I have to follow the structures of data sufficiency. For those who are not accustomed to data sufficiency, look at my video on data sufficiency, please. I put in structures of how you need to work with word problems. Speed, distance, time questions are word problems themselves, right? So you follow the same structures when you work with the data sufficiency. What are the structures for working with the word problem? First, ensure that you spend time on the question stem. Spend time on setting up the question stem. Make a note of the constraints. Define all your variables in the question stem itself. Translate the question and set up the question as an algebraic equation. And then once you're clear about what you need to solve, ask yourself, what kind of data sufficiency question are you dealing with? Is there a value? Is it a yes, no? Respect the different types. Work your way through the statements. If it's a speed, distance, time question, I will integrate the process that we've learned so far along with the data sufficiency process. I will still use the table. And I would set things up, but I would integrate the data sufficiency process. I would spend a lot more time on my question. I would define my variables. I would set my question up as an algebraic equation, and only then would I go into the statements and work with it. All right. Okay, so let's give the question a shot. Let's start with an easy one first, build the process, and then go into a couple of slightly more difficult ones. Again, I'm sticking to an official guide question. Give it a shot. See, official questions, somebody's asking me about GMAT club questions being tad bit more difficult. I would say explore GMAT club questions after you've exhausted the official questions of that topic. Okay. It does give you harder questions, which I think hold you in good stead if you work, right? I wouldn't, obviously, I would check the source. I would look at GMAT club as a source, trusted prep companies as a source. Anything that is other or any cat kind of questions, I wouldn't even attempt doing. Okay. So official questions first, please. And that's what I'm doing as well. And that's what I've done in all my sessions, right? You'll always find that there's a good chunk of official questions, and then there will be some questions from other resources that I bring in. very easy one to start with. I want you to integrate the process of working with the data sufficiency along with what we did in speed, distance, time. Form the table, spend time on the question, set the question up, define your variables, set up the question as an algebraic equation, see what you need to solve for, then move into the statements. You can start typing your answers in the chat window. Another minute and we discuss. No, it's like it's a data sufficiency question, right? So you're expected to see whether the statements individually give you your answer or whether the combined they give you your answer. Okay. So remember what we discussed in the data sufficiency session. If you've not gone through the data sufficiency session of mine, I encourage you to do so, especially if you're started the word problems. When you started learning word problems, it's best at that point to integrate and learn the data sufficiency process of working and keep practicing. Okay, going forward, don't leave your data sufficiency practice towards the end, please, because you need a lot more practice on the DI section than you require for quant and verbal, right? So what I said in that session basically is when you work with word problems in a data sufficiency, spend more time setting up the question stem. Make a note of the constraints, define your variables, set up the question as an algebraic equation. And since we are dealing with a speed, distance, time question, I would want to set it up, integrate the process of using that table here as well. So I have distance, I have speed, I have time, and I have only one person moving, Helen, right? So what does it say? How many hours did it take Helen to drive from a house to her parents' house, right? So it's how many hours. So I'm going to say let the hours be X. I don't know what Helen's speed is. So let me keep Y kilometers per hour. So the distance will be X into Y kilometers, right? And the question is asking me to solve for X. You see, even though I know I don't have anything much to do in the question stem, I'm still defining my variables in the question. I'm limiting the variables that I choose and I'm setting the question up as an algebraic equation so that once I define everything, it becomes a very easy translation with what I have in the statements. I'm also boxing up what the question's asking me, putting a question, and I know this is a value data sufficiency question. So I'll need a definite answer for me to say something is sufficient or not. Now I'm going to go into the statements. What does the first statement tell me? Helen's average speed on this trip was 72 kilometers per hour. So they're giving me the value of y. Giving me y is equal to 72 kilometers per hour is not going to help me figure out what is the value for x. I don't know, right, what x is, right? So giving me y is not helpful for me. So clearly insufficient. BCE. Second, if Helen's average speed on this trip had been 8 kilometers per hour greater, so let's now again use the table. Don't carry information from the first to the second. Look at the second in isolation. If Helen's average speed on this trip had been 8 kilometers per hour greater, what have I taken as a speed? Y. So now they are saying it's y plus 8. It would have taken her 1 hour less to travel that same distance. So it should have taken a x minus 1. And that distance will be now what? X minus 1 into y plus 8. And I know the distances are the same, right? The distance that she's traveling from her house to her parents' house has to be the same in each case. So I know the equation that I have is x minus 1 into y plus 8 is equal to xy. Try to work with it. Remember, I need to solve for x. So xy plus 8x minus y minus 8 is equal to xy. So the xy cancels. I'm going to isolate the x. So 8x is equal to y plus 8. I have absolutely no information about y in the second. I can't solve for x. Clearly insufficient. Out goes B. And once I prove the two statements individually to be sufficient, I'm going to combine the two. So combined information tells me y is equal to 72. I already have 8x is equal to y plus 8. I can put the value of y here, solve for x. That would be enough for me to work. C. Start with an easy one. This is how you would set it up. I'm integrating the process of working with speed, distance, time with the table along with data sufficiency as well. Right? Spend time on the question. Define your variables, put it in a nice tabular form, work your way through. All right? Let's try one more, a slightly more difficult one. Let me pick a difficult one slightly for you. Yeah. Not a very difficult one, but a slightly more difficult one than the previous. Give it a shot. Question 17. This is the last question, and we'll wrap up with this. Remember, guys, again, it's how you set the question up. Once you set the question up, define all your variables, it just becomes easy then for you to translate the statements and work. When you're working with the statements, work towards what the question is asking you to solve. Okay, you can start typing your answers in the chat window. Not sure about two. Translated well. Normally, percentage data, right, becomes a little confusing. When they say 25% faster, think about it as 125%. So 125% is 5 by 4, right? Look at it like that. Reduced by 20% means 80%, right? 80% is 4/5. So set up your algebra based on that and then simplify and see what happens. A wonderful question this is, okay? A beautiful question. And this is how they would trap you on certain things, okay? Very simple one, but it has a lot of things to learn from it. When to chase a statement, when not to. Okay. Khalil drove 120 kilometers in a certain amount of time. What was his average speed in kilometers per hour during this time? Not too bad. Very less data for me to set up, but let me do that. So he drove 120 kilometers. This is Khalil. In a certain amount of time. What was his average speed in kilometers per hour? So let's say he travels for X hours. So his speed should be 120 by X kilometers per hour. Right. So I've defined everything that I can possibly do in the question. They're asking me to solve for 120 by X. Now, there's nothing more I can do with my question stem. So I move to the first statement. So what does it say? If Khalil had driven an average speed that was 5 kilometers per hour faster. So again, let me put my table. If Khalil had driven at an average speed that was 5 kilometers per hour faster, so that's 120 by x plus 5, his driving time would have been reduced by 20 minutes. So 20 minutes, remember? So 20 minutes is 1/3 of an hour. So x minus 1 by 3 hours. Right? And that would be 120. So I know that 120 divided by x plus 5, speed into time is your distance, into x minus 1 by 3 is equal to 120. Now I would not stop here and say I have one variable and I have one equation, I can solve for it. No, I don't know, right? The variable may get cancelled out. I don't know what to do with it. So it's better for me to open it up and work. So I have 120x times x, that will be 120 minus 120 by 3x plus 5x minus 5 by 3 is equal to 120. This goes. So I have 5 by 3 is equal to 5x minus 120 by 3x. Right? I know it's a quadratic equation. I can definitely solve this quadratic equation. And I know in a quadratic equation, I cannot have two different times to give me two different speeds, right? It can only be one specific time. So whatever values I get, there's a high chance one will be a negative. It will not be both positive, right? So I can stop at this point because I know I'm going to get a quadratic. Nothing is canceling out. I can solve for x. I can get to an answer. Sufficient. AD. Now let's go to the second statement. Let me use some more space here. So what does the second statement tell me? It's again all about translating what I have and then simplifying and then observing. If Khalil had driven at an average speed that is 25% faster, so again DST, I know these are the original time, distance, and speeds he traveled. If Khalil had driven at an average speed that is 25% faster, so he's already traveling at 120 by x. 25% faster means 125%. That's 5/4 of 120 by x. You see what I'm doing? 25% faster in my mind. 25% faster means 125%. 125% is 125 by 100. That is 5/4. So 5/4 of 120 by x. His driving time would have been reduced by 20%. So if it's reduced by 20%, it's 80%. 80% is 4/5 of x. And I know that again has to be 120, right? So 5 by 4 into 120 by x. This is 120. This has to be into your speed into time should be your distance. Into 4 by 5 into x should be equal to 120. See what happens in this. The 5 cancels. It's like cyclic, you know, cyclic logic, right? 4 goes, x also cancels out, and I'm going to end up getting 120 is equal to 120, which is like cyclic logic. It's not giving me a value for x. I need to solve for 120 by x. For me to solve for 120 by x, I need the value for x. So this is where you'll have to do the working. Even in the previous case, what did I do? I opened the brackets. Then I observed that my variables are not canceling out. If I simplify, I'm going to get a quadratic. I'm not going to waste my time working at quadratic. I know the quadratic is going to give me an answer, and that answer has to only be one answer because I can only have one time that can give me one specific speed. So now if it's giving me 120 is equal to 120, it is not giving me any information to solve for x. Clearly insufficient. Alpha, that is my answer. So you see, even when I'm working with data sufficiency, I am not deviating from the process of working. I'm sticking to the same process and I'm just integrating the process of a data sufficiency, a word problem data sufficiency along with it. Got it? This is how I perceive and look at this entire topic of speed, distance, time. Very tricky topic, tricky to learn, tricky to teach as well, because the focus always has to be on reading, processing, organizing, decision making. And then comes the algebra towards the end, right? So it becomes a little difficult for test takers because they don't focus on the reading and the processing and organizing of the information. So I hope the session today helps you do that, helps you focus on how to organize data, helps you visualize things better, and also gives you multiple approaches of working with the speed, distance, time question. All right. So that's the last one. The session will be is recorded. I will upload the worksheet in maybe a day or two. And the questions that I have not solved during the session, I will write explanations to them and I'll put it in the form of a PDF. Okay, so anybody wants to look at the videos can look at the video and go through the PDF as well, similar to all my other sessions as well. So this is my second last session, with GMAT Club. I will also maybe see you in a couple of weeks' time, 2 to 3 weeks' time, for the last topic, and that would be absolute values. Okay, I'll give you a fresher perspective of absolute values tailored to the focus edition, and that's your topics, the harder topics on GMAT focus edition that you can use as the reference. And I hope that playlist helps most of you all out. Thank you for all the DMs that you sent. about the playlist and how it's helped you out. Thank you also for viewing the videos and asking me questions as well. um, I may have missed out on some of your emails because of the number of emails that I have. I apologize for that, but I'll try to do my best to catch up on the emails that I have. All right. I don't have a sequences video anywhere yet, because sequences is a part what I do with statistics. It's a part of statistics. I deal with sequences a little differently. I don't do it as a separate concept of sorts. Okay, so it's a number properties and algebra mix, but I do it under statistics. I don't do that. Okay. Is there any way to get personal sessions? Yes, I do take personal tutoring. You can reach out to me on LinkedIn, or you can reach out to me on my email ID. You can find my LinkedIn profile on any one of the videos that I have. My email ID is also there. You can reach out to me and we can have a discussion on that. My advice, um, I always recommend taking personal tutoring after you've done a good round of prep, because you're aware of what areas you need help on, so you can reach out to me for those specific areas. All right. Just wanted to check that the concepts you explained would be sufficient to solve. Absolutely. Right. Any topic that I've discussed on GMAT Club, guys, um, for example, inequalities, speed, distance, time and work, probability, I have exhausted everything from a concept standpoint. Okay. The concepts that are required for that topic is already put in. All you have to do is use those concepts and structures to solve questions. You'll get different variations of questions, but the foundations of what is required to solve those different variations are already put in. Okay. That's one thing that I always focus on, because that's how I teach. My focus is always on going in depth in the understanding of the concepts. All right. There are a lot more variations that the GMAT doesn't test on, right? But the examples that I've taken, the content that I've given you is enough to solve any GMAT speed, distance, time questions. Okay, it's actually more than what, because I normally would not work with relative speed. There is another process of using ratios as well that I did not explore at this point, because it just make the session too long. So yes, the short answer to your question is yes. Right, I do exhaust all the concepts that are required. All right. Okay, last call. Questions? Any questions? And then we'll wrap up. It's been a long day, and I think most of you will have a long weekend to look forward to. Thank you, Shika. Earlier than 3 weeks. No, guys, I think um, I think 3 weeks is a good timeline as well. You have a lot more things to do as well, right? With a lot of other tutors adding value in terms of DI and verbal. So I think you should also go and have a look at all of their videos. Wonderful work. I think some of the tutors are doing as well. I've seen some of the videos on verbal, and it's been great, right? So thank you for all the kind words. Um, I will wrap up at this point. I will see you in 3 weeks' time for my last session on absolute values. Good night. Have a great weekend.